Yeah, hello, can you hear you? Good evening.
Hello, I hope I'm audible. It's
Yeah,
afternoon here in Nairobi.
yeah, good afternoon there. Yeah, you're completely audible. We are going to start in few minutes. Yeah,
Yeah,
good
hoping
evening.
to
Yeah,
hoping to learn more.
yeah, sure.
Thank you. Shukriya.
Yeah, good evening, Prakash Rao. Yeah, good evening, Jay Kumar. Yeah, good evening, guys. We are about to start shortly. Just waiting for a few more to add up. Yes, so by 6:05, we will start exactly. Yeah, hello everyone. Before we go ahead, I'd like to make a request to all the candidates. They can mute their calls, okay, as well as their video. Okay. The reason being is it's good for you also. You get proper bandwidth. Okay. There is no disturbance in the call if you keep your mic muted. Okay. When you have any doubt, if you have any doubt, you can connect at the end. We have a query session. Okay. At the end of this webinar, we will have a query session. In that query session, you can ask your doubts. Okay. We will be open for your doubt. Okay. We'll be starting shortly in 2 minutes. If during the call, due to some glitch, if the trainer gets disconnected, don't worry. We will join back again if there is a problem. Okay, but you are requested to stay connected in case of any problem. Okay. So I guess Divyani, yes, you are good to start. I'll start the recording.
Yeah.
Yes. Other candidates, kindly mute your mic. Yeah.
Hello, sir. Am I audible?
Yes, you're.
Yeah. Thank you, sir. Hello, everyone. This webinar is basically on your four-wheeler battery. First, we'll try to begin with the very basics things. I'm just sharing my screen.
Yeah, Divya, 1 second before you
Yes.
start. Just 1 second.
Okay.
See, it's a small announcement for the group, okay, for the candidates, that a certification will be distributed after this webinar, okay, for your attendance. So you're in the chat box, you have one form, attendance form. Okay, you can fill it whenever you want after this webinar also, during this webinar also, and so that we can dispatch your e-certificate on your email IDs. Yeah, Divya.
Yeah. Okay. We'll study about the basic components of battery, mostly the introduction, and later on we'll cover the advanced topic as well. Okay. First, this particular slide shows about how the battery manufacturing happens, from very basic things. If you see, the first step is about, I can ignore some background noise. The first step is about processing, raw material processing. In that, it includes battery manufacturing.
Divya, you are muted.
Okay, fine. Yeah. Now I'm audible, right?
Yes, you are.
Yeah, thank you. Yeah, I'm just telling about the introduction to the battery technology. In this, we will see about how battery manufacturing happens, how it is assembled in your vehicle, what was the stage of the battery when you have used it to 10 to 15 years. So what is the life of the battery after that? The first stage starts with your processing of materials. In that, we will process the raw materials. It may be your lithium, it may be your nickel, cobalt, all the raw materials which are needed for your battery, which are essentials for making cells, have been processed in the stage. Step two is your battery cell production. In that, we will process all the raw materials which we got here and we will assemble them in the form of cell, which includes all your electrode, separator, electrolyte materials and everything in a cell structure form. Now this particular cell is ready to act as a small storage unit. In step 3, if it is of module production, in this we will assemble all the group of cell in the form of modules based on the voltage capacity we need. Okay. Next is the pack. In this, all the modules which you have already done in the module production stage will be integrated in the form of large battery pack. In this, we will include BMS also in it to monitor your temperature, charge, and also to take care of your safety issues. And step 5, we will integrate all the BMS in the vehicle with some chips and power controllers as well. And the last stage is recycling or second life. After you have used your battery for some 10 to 15 years, when that battery voltage is dropped down to some percentage, where you can't use it for your vehicle furthermore, then we will go for recycling or second life of your battery. In this, we will reuse it. That means even though we can't use it for your vehicle, but the battery is still functionable. So in this stage, we will use it for a secondary applications like energy storage systems for your wind or solar energy. Next, we will refabricate it. That means we will reassemble all the batteries, all the parts inside your batteries, and we will try to meet the new voltage and capacity requirements that we need. Next is recycling, in which your battery is completely recycled. Based on the, we will consider environmental friendly options here. And next slide shows about the advantages and disadvantages we have in lithium-ion batteries. We are using lithium-ion batteries in electric vehicle. It has some advantages and disadvantages as well. First advantages is it has high energy density. This is the one of the important reason why we are using lithium-ion battery in your electric vehicle, because of its energy density. We'll cover about this in the next slide. Next, we don't need any kind of priming. Priming is that before using a batteries, we will just charge them initially. That we will call as priming. Before using your battery for the first time, we will charge them. That's what we call as priming. So in case of your lithium-ion batteries, there is no need of priming. Regular charges all we need. Next, the self-discharge rate is less and half than the nickel-based batteries. Self-discharge rate is itself, if you are not using batteries and you're keeping it aside, the battery itself discharges it due to its self-discharge capability. That is less compared to your nickel-based batteries. And the maintenance is low. Specialty cells can provide very high current to applications such as power tools. We can use this in the power tools because they can give you high current. And we do have some disadvantage as well. As this is, we are dealing with voltage and current, it is required to have some safety limits. Because even if a small change of the exceeding of your voltage and current may leads to a thermal runaway, which is a prone to the safety. So that we don't want that. So it is required to maintain some safety limits of your voltage and current. Next, there is a chance of aging. If we not use the battery, if you are not using it battery, your battery will get aged. So to prevent this, we need to store it in a cold place. That time we can only reduce 40% of that effect. Okay. So we need to store it in a closed place at 40% of charge to reduce that aging effect. Next, we have some transportation restrictions. When we are shipping a large quantities of batteries, we need regulatory control on it, as your batteries are having high amount of energy in it. If this is expensive to manufacture, about 40% is higher than the normal cost of your nickel cadmium. And this technology is also not completely mature, and many kind of innovators are coming in this technology. So this is introduction to your battery tree. Your battery is a part of your electrochemical storage source. So your battery is also a part of it. And if you see, there are other parts also as well. Electrochemical stores, that is your ultra capacitor, batteries, and fuel cells. In electric vehicles, we seen they have using ultra capacitors along with batteries, because ultra capacitors are having high specific power. That means in less duration, they can release more amount of power. So that is the reason we are using ultra capacitors. Maybe when your battery is at starting stage and when you want to give acceleration, that time you can go on your ultra capacitor. When some particular rate or the acceleration has been picked up, then your battery can take on. Next, we have fuel cells. So hydrogen fuel cell is one of the examples to it. When you supply fuel, so chemical reaction happens and electricity will be the. Okay, and batteries also, we do have different kinds of batteries: lead acid, nickel based, ambient temperature batteries, which work on the room temperature, and we have high temperature batteries as well. Yeah. In the previous slide, during the advantages of lithium-ion cell, we have seen that lithium-ion cells are having nice energy density. That is one of the main reasons that we are using them in your electric vehicles. What does this energy density and how lithium-ion cells are managing it? So if you, this particular picture shows the comparison between your energy density, specific energy density, and volumetric energy density. If you see the comparison of different battery types, lithium-ion cell is managing it both volumetric energy density and specific energy density. That means this particular battery can store more amount of energy in less space when you compare to other battery types. Okay. And this is the reason why we are using it, because the weight is the important factor we have to consider during electric vehicle. Because if you see, there are mostly 4 kinds of forces which acts on your body: the aerodynamic drag, rolling resistance, acceleration, and gradient force. In this, both your rolling resistance, acceleration, and gradient force will have a letter M in the formula. That is your gross vehicle weight, which includes both your vehicle and the passenger's weight as well. So it's better to decrease the weight so that your range of the vehicle can be increased. So this is about your battery components and structure. So your battery will have 3 main components: anode, cathode, and separator. So anode is responsible for charging time. And you see, this is mostly made up of graphite. And we have separator, which acts between your both anode and cathode. It is there in between. It doesn't allow the flow of electrons, and it acts as a barrier which prevents both anode and cathode to touch physically. And in cathode, we will use different kinds of components. Even in lithium-ion cells, we mostly solely not use lithium, but we'll use the combination, either combination with cobalt or combination with magnesium, manganese and all. And during charging, the electrons will move from your cathode to anode via some external circuit, and during discharging, the path will be different. Okay, and the lithium ions also will move from your cathode to anode only, but they'll move inside your battery through the separator. So this is how mostly your battery will function. So this is how your battery is integrated inside a vehicle. If you see, this is a Volkswagen company's one. So if you just observe the design of it, it contains many parts. If you see the upper part of housing, so this upper part of housing, it acts as a protective layer, and it acts as a protective layer and ensures that the battery structure is maintained. And we have, if you just see other thing, we have cell management controller, which manages your cell. And we have high voltage connector. It used for the energy transfer into the battery. And we have connector strip. This is ensures that the electric flow will be there inside your battery.
Hello.
Control strip, it streamlines the electric flow in throughout your battery.
Hello.
Hello. Yes, Mohammed Siraj, are you saying something?
Yes. Good evening, sir. Sir, क्या बोल रहा slide?
Hello. Please continue, Divya.
Hello. Hello, sir.
Yes, yes. Are you saying something?
सर समझ में नहीं आ रहा सर, स्क्रीन शेयर करवा दीजिए.
अच्छा, आपको प्रॉब्लम हो रहा है? ओके, ओके. Divya, please continue in both languages, Hindi and English. Okay.
Yes, sir.
Okay. Okay.
Okay,
Hello.
thank you, sir. Thank you, sir.
Yeah. So battery management system is just हमने अभी जो previous slides में देखा है, it is used to maintain your battery's overall health. It also include कि आपका जो current का measurement है, temperature का measurement है, that factors also include in your battery management system. And we have this battery housing, ये एक additional layer provide करेगा. And next we have this place plate with cooling system. This is a very kind of new one कि where कि आपको एक base के ऊपर you will find some cooling system as well. This base will not only give you the structure but also maintains the battery optimal temperature so that your battery performance जो भी है वो उसकी जो lifespan है वो बढ़ सके. Okay. So this is the comparison between different types of lithium-ion batteries. तो lithium-ion की में भी different types का chemistries है उसके अंदर भी. तो इसमें हम उस chemistries के comparison देखेंगे, different lithium-ion chemistries की. पहले first is lithium cobalt oxide and lithium magnesium oxide. If you see the voltage जो भी है lithium cobalt oxide की 3.6 volts है और lithium magnesium oxide की 3.7 volts. And specific energy 150 to 200 watt per kg जो lithium cobalt oxide की है and C rating 0.7 to 1 C. So ये 4.2 volt तक. If the most of the cells have reached 4.2, then you can charge it from 0.17 to 1 C. ये 3 hours का भी चार्जिंग कर सकती है, but mostly हम जो भी चार्जर है, if the C rate is less than 1 C or equal to 1 C, वो हमारे लिए फास्ट चार्जर है. अगर उसकी चार्जिंग 1 C से ग्रेटर है, 1 C से कम है, then we will call it as slow charging. Okay. So हम mostly हम अपना जो भी चार्जर है will try to increase कि वो जो भी आवर है 1 hour से ज्यादा चार्ज करें so that our battery life can be safe. And we have discharge rate also. both charge rate and discharge rate जरूरी नहीं है दोनों सेम ही रहे, it may be different. And we have cycle life 500 to 1000. Thermal runaway, this can sustain up to 150 degrees centigrade of temperature. जो एप्लीकेशन है ये हमारे मोबाइल फोन्स में, टैबलेट्स में, लैपटॉप्स में और कैमरास में इस टाइप की बैटरी यूज करते हैं. और इसकी जो मैग्नीशियम ऑक्साइड की स्पेसिफिक एनर्जी है जो 100 to 150 वॉट आवर है, चार्ज रेट 0.7 to 1 C है और डिस्चार्ज 1 C, 10 C also possible with some cells. और उसकी साइकिल लाइफ है 300 to 700 है जो हमारी LCO से कंपेयर करें तो कम है. एंड इसकी थर्मल एनर्जी ज्यादा है 250 डिग्रीज ऑफ सेंटीग्रेड। इसका मतलब है ये हाई चार्ज प्रमोट कर सकता है। एंड नेक्स्ट इसकी एप्लीकेशन है पावर टूल्स, मेडिकल डिवाइसेस एंड इलेक्ट्रिक पावर ट्रेन। Next, lithium, nickel, magnesium, cobalt oxide. Its voltage is of 3.6 volts and specific energy is 150 to 220 watt hour per kg. C rate is 0.7 to 1 C. Discharge rate है 1 C और 2 C भी possible है। Next, cycle life 1000 to 2000। ये जो cycle life है, it related to your depth of discharge and temperature. Depth of discharge in sense it is the
इलेक्ट्रिक व्हीकल की बता रहा है ट्रेनिंग।
it is the usable capacity of your battery. If say कि we have seen in the previous slide in the lithium ion one disadvantages कि ये जरूरी है कि that we need to set some limits for your both voltage and current. So if suppose मेरी जो cell है, if I have set it some limit that कि ये जो 50% की charging है, if it reaches some 50% charge, इसके बाद वो discharge नहीं होगी and its charging won't be possible after 95%. So now इसकी जो usable capacity है जब वो है सिर्फ 80%. That is what we call depth of discharge. So हमारा जो cycle life है, जो depth of discharge और जो temperature है उसके related की होगा. It may be around 1000 to 2000. वो depend करेगा आपके depth of discharge और temperature पे. And thermal runaway 210 degree centigrade. ये cost है इसकी $420 per kg. एंड ये हम ई बाइक्स पे, मेडिकल डिवाइसेस पे, ईवीज पे, इंडस्ट्रियल पे यूज कर रहे हैं। नेक्स्ट इज लिथियम आयरन फॉस्फेट IFP. सो इसकी वोल्टेज है 3.2 एंड इसकी स्पेसिफिक एनर्जी है 90 to 120 watt hour per kg. इसकी सी रेट है 1 C. डिस्चार्ज रेट इज 1 C और 2.5 C बेस्ड ऑन द सेल्स। साइकिल लाइफ है 2000 और उसकी हायर भी है। दैट मीन्स आपकी जो साइकिल लाइफ है 2000 से भी ज्यादा हो सकती है इफ यू मेंटेन दिस डेप्थ ऑफ डिस्चार्ज एंड टेम्परेचर। थर्मल रनअवे 270 डिग्री सेंटीग्रेड विच इज हाई। सो ये वन ऑफ द सेफेस्ट बैटरी है पर इट इज कॉस्टली एज वेल। ये बैटरी हम पोर्टेबल और स्टेशनरी डिवाइसेस में यूज कर रहे हैं व्हेन हाई करंट एंड्योरेंस की जरूरत है। Next is lithium, nickel, cobalt, aluminum oxide. Its voltage is of 3.6. Its specific energy range around 200 to 260 watt hour per kg. Its C rate is 0.7 and discharge rate is 1 C. Cycle life is 500. Same. It depends on your depth of discharge and temperature. Thermal runaway is 150 degrees centigrade. Cost is $350 per kg. एप्लीकेशन ये हम मेडिकल डिवाइसेस, इंडस्ट्रियल और इलेक्ट्रिक पावर ट्रेन। टेस्ला की जो कंपनी है उसकी इलेक्ट्रिक पावर ट्रेन में दे आर यूजिंग दिस बैटरी। लिथियम टाइटेनेट।
Excuse me.
Yes.
Sorry to interrupt, but could you please explain the concept of thermal discharge? Sorry, depth of discharge and thermal runaway once again.
Yeah, sure. So depth of discharge is nothing but if you have a battery, we will have some level ki after this level it won't be discharged or charged. So if I have some battery, if I have set it some 50% and 95%, so that my battery can't charge after 95% nor it can be discharged after 15%. Now this capacity which is there, that is the capacity which I use, right, which is 80%. That is what we call depth of discharge. Okay, and about thermal runaway, there are many reasons for thermal runaway. It may be your mechanical abuse, electrical abuse, or due to temperature. So mechanical abuse in sense, if some nail is penetrated on, if something happens, hampered the mechanical structure of a battery, then जो separator है, which is in between your cathode and anode, it will get disturbed. Due to that, your battery will get short circuited, and slowly it goes to your smoke, fire, and explosion. That is what we call as thermal runaway. Okay. I hope the point is clear. Hello. Hello. I hope your doubt is clear. Okay. For your lithium titanates, the voltage is of 2.4 volts and specific energy 50 to 80 watt hour per kg. C rate is 1C. We can go it for 5C also maximum. Discharge rate is 10C. Cycle life 3000 to 7000, which is higher compared to your previous batteries. जो हमने previous batteries देखी है उससे ज़्यादा है. And this is one of the safest lithium ion batteries. But इसकी cost है, अब if you compare with the previous battery, सबसे ज़्यादा है. इसकी application it is using in your electric powertrain and solar powered street lighting. So next is about form factor. Form factor is nothing but your shape and the structure of your cell. Okay, there are three types of form factors. Or simply saying there are three types of shapes or structures of your cells: cylindrical cell, prismatic cell, and pouch cell. So these cylindrical cell will have high mechanical stability due to their shape, and the pressure is also distributed uniformly. But the problem is, in case of cylindrical cells, space may not be utilized fully, and the thermal management or the heat management to the cell is also good. Prismatic cell, it will have more stresses at corners due to its shape. The space is used optimally. We need to have some thermal management system, which is costly. There's no gaps between cavities. Pouch cell, in pouch cell, the space is used more efficiently, but if this pouch cell is exposed to your humidity or temperature, the cell life will get low. And in the pouch cell, there's a problem which is common as swelling. Or electrode and separator are stacked rather than doled. In case of your prismatic cell, जो आपकी electrode and separator है, वो rolled होंगे. But in case of your pouch cell, they are stacked rather than being rolled. Yeah. Hello, Vasheel, are you there on call?
Yeah, hello
Yeah, Divya.
everyone. Before Vasheel takes over from here, I'll just like to remind the participants that in the chat box you have a link for your attendance. So kindly fill that attendance so that you get a e-certificate from us. Okay. Now, Divyavani gave an introduction about the lithium-ion battery, its manufacturing process and all. Okay. Next, Vasheel will be talking more about blade chemistry, blade lithium-ion battery (LFP), which is generally utilized in the Mahindra B, which is our main crux of the topic. Okay, we are going to explain the Mahindra B battery pack. Okay, in detail. Okay, so before that, we need to understand one cell. Okay, one cell of that BE battery. Okay, which is called as blade LFP. Okay, so Mr. Vasheel will be taking over from here for blade LFP. Okay, and after a few minutes, I'll be taking over for the further part. Yeah, but it's a reminder once again to the participant, kindly fill up the link. Vasheel, you can take over.
Thank you, sir. So, hello guys. I think Divya ma'am has told you about the batteries introduction and different batteries geometries. Okay. So now I want to take about your blade battery. Okay. So why we need your blade battery? Okay. So first of all, as Divya ma'am told, there are I think three chemistries. Okay. On cell, on cylindrical. Okay. Then next is your prismatic. Okay. And next is your pouch. Okay. So out of these three, the maximum capacity in less space, okay, we will have your prismatic. Okay, so if I use my prismatic, I think if you check in go surf in your Googles, okay, you will that your prismatic you will get high capacity. Say it's around some prismatic will be 60 amperes. Okay, that much amount of capacity in less area. Okay, so if I want for my four-wheeler, what I need to utilize space much more efficient. Okay, so that time I might choose your prismatic. Okay, compared to your cylindrical and pouch. So your pouch is mostly used in your phones and laptops. Okay, where your space is restricted and the size is restricted. Okay, and cylindrical and prismatic we mostly use in your cylindrical we mostly use in two-wheelers, and prismatic and cylindrical we use in four-wheelers. Okay, so now this new technology, which is blade battery, this has been patented by your BYD, okay, a China-based company, okay. So their innovation that the blade, okay. So we know अब blade का मतलब क्या है? आपका fan का blade, वो lengthwise पर होगा, okay, lengthwise पर बड़ा होगा, okay. So ये क्या कर दिया, okay, ये आपका मॉड्यूल है ना, आपका मॉड्यूल, okay, एक मॉड्यूल और आपका बैटरी पैक, उसका लेंथ को ये डिमेंशन पर कंसिडर कर दिया. ओके, सो आपका ये बैटरी पैक उसका एक डिमेंशन आपका मॉड्यूल का लेंथ होगा. ओके, टेक एन एग्जांपल, आपका मॉड्यूल का लेंथ है 100 mm. ओके, सो आपका ब्लेड बैटरी इस लेंथ विल हैव क्लोजर टू 100 mm. ओके, सो दे विल हैव बिगर लेंथ, शॉर्टर विड्थ. ओके, whereas आपका you can see in your prismatic it will be like a rectangular. Okay, rectangular or square type. Okay, whereas your blade will be a long, you can say a wider rectangle. Okay, so that's the one thing. So the reason why they shifted or why they innovated this blade is that first is your capacity. Okay, so आपका capacity का मतलब क्या है? Any idea? Any answers from your end? आप बैटरी का कैपेसिटी है ना, उसको हम क्या करते हैं, क्या कहते हो? बैटरी का कैपेसिटी का मतलब क्या है? एनीवन? वो AH है ना, उसका यूनिट. ओके, AH है ना, एनर्जी स्टोरेज. एनर्जी स्टोरेज है ना, कितना वो एनर्जी स्टोर कर सकते हो. ओके, सो एनर्जी स्टोरेज का मतलब क्या है? आपका इलेक्ट्रॉन्स है ना, वो यहाँ पर अक्यूमुलेट होगा. ओके, करेक्ट है ना, आपका आयंस यहाँ पर अक्यूमुलेट होगा. ओके, कंसिडर लाइक अ रूम. ओके, इफ यू हैव बिगर रूम you will have bigger, more people can come, right? अब बिगर रूम है, ज्यादा लोग आएगा. छोटा रूम है, छोटा लोग आएगा. Okay, so like this only your capacity works. Okay, so what I'm doing here in blade, I'm going to keep my length high, so high which will increase its area. Okay, overall area. Okay, thus increasing your capacity of your battery. Okay, so this blade can go up to 100 or 120 Ah, okay, with less area. Okay, this is like a peg like this only. Okay, the length here rectangle, this does not have any thickness, so we can just accumulate more and more. Okay, so that's the first advantage. I think Prasad, I think my voice is coming, right?
Yes, sir.
I think Prasad,
Yes,
you need
sir.
to check your net. Okay, okay, so till now is that clear, right? Why we are shifting to blade? What is the difference between prismatic और blade? Clear है ना? और कोई query है?
No, sir.
Okay, then so the first is your more capacity.
Hello.
Yeah, Krishna.
Am I audible?
Yes, yes.
So, what is the difference to use the prismatic battery and blade battery? If we increase the number of the prismatic battery, suppose the area of the blade battery is like 1000, and if we increase the same area with the prismatic battery, then what will be the difference?
See,
They both have the same AH value. They both have the same. If we make the same AH value and same capacity, then is there any difference with
yeah.
the prismatic and blade?
Okay. So I'll tell you, okay, the main difference is your distance, okay. So as I increase my capacity here, this will become bigger, which means the space I need will reduce, okay. My ultimate aim in four-wheeler what? I need to get maximum space utilization, okay. That's my major aim, right? So in prismatic, the thing is that I am increasing both length and width. I'm increasing both length and width in this geometry. Okay, kind of like a square, around like a square. Okay, so as I increase my capacity H, this will get bigger. Okay, so but whereas here in your blade, okay, so I show this blade will, I'll just show you. Yeah, so this will look like this. Okay, a thin, somewhat less thickness type of rectangle. Okay, this focus on your length. So this length, this covers your one dimension of your battery. So here you can see how much I can able to accumulate. You can see, right? I can able to stack more and more, right? So I can able to utilize my space. One thing. Okay. So that's one thing. Next, I will tell you. Let me just play this video. Okay. Just hold on.
Uh,
Okay.
shall I interrupt you right now here?
Yeah, Krishna.
See, my concern is that for the manufacturer, they are going to manufacture the blade battery. The length is so high, and in the battery pack, uh, if we use that prismatic battery, then the number of the prismatic in the module will be high in term of blade battery. Am I right?
No, the prismatic will be less because it's bigger, right? I'm getting, I will be
Uh,
able to come put less only prismatic. I can able to stack more blade, but less prismatic.
what will be the cost of the prismatic and the blade? Which will be the more, the blade one or the prismatic one?
I think cost wise, I think maybe, I think, I'll say someone. In cost wise, I think blade, I think it will be, since it's a newer technology, I think it will be much
Yeah.
more higher compared to the older one, which is prismatic, okay? But
So my
it's a,
concern was that
mm,
uh, if we are manufacturing the battery pack, when
mm,
uh, after some time
mm,
that will be like uh, some of the cell will be down, or may some of the pressure difference will be decrease in the battery pack.
mm.
So at the time of repairing that, it I think it will be more easy and effective to replace the prismatic one regarding the blade one.
No, I would say, since blade also much more, like I say, I think say blade is much more easy maintenance, okay? I'll tell you why, okay? See, in prismatic, I just split it into modules, okay? Modules, and I just packed it here, okay? So blade is like, you can say like a stacking thing, okay? This cover in the dimension. Just take it and remove it, okay? Prismatic's arrangement, you can say like connecting of each prismatic is difficult compared to blade, okay? That I'll tell you, okay? How the connections of blade is, okay? Then you will understand. It's just simple locking, okay? Compared to a prismatic, this is simple locking of each blades. So I can easily able to remove one blade and another, place it another, okay? And in your prism, yeah. And next is your prismatic, the safety issues also there, okay? Your prismatic has is more or less safer compared to your blade, okay? That I will show you, okay? The video you why it is less safer, okay? So if I am a battery manufacturer, okay, four-wheeler, okay, if I don't care about the cost, because as years goes on, the cost will definitely reduce, okay? My priority is to get more range and more safety, right? The cost will definitely reduce, okay? As demand highs, the price will definitely reduce, okay? So that's why I'm saying the blade is the new technology, and that's why Mahindra has chosen. Okay, this is the imported one. Okay, they haven't done the manufacturing yet. Okay, we imported from BYD. Okay, they only did the R&D. They only made it. Okay, in further future, we may try to replicate it. Okay, you got it? Why the reason they move it from prismatic to blade? Okay, you can also use prismatic. It's not like prismatic is not your waste and all. Okay, I'm saying this like an advanced way. Okay. Clear, right? Shall I just move on?
Mr. Vasheel, so when you say Mahindra has adopted this, this is a new technology, does that mean others are still on prismatic?
That I'm not sure. Okay. Right now we got again, not others. The China BOID company.
Uh,
Give me one second. Second.
sorry, sorry to interrupt you. As per my experience, I have seen lots of the battery module, the Chinese manufacturer and the Indian manufacturer. Tata also used a prismatic. I heard from you that the Mahindra B are using the blade battery, but I think they have imported from the China from the
Yes.
BYD.
Yes, they
And
imported it.
even the cattle, they haven't, they are also using the prismatic form.
That's what I'm
And
saying. It's gonna be
and
coming.
Yeah, Mr. Krishna, I'll take over from a bit. Vashil, just give me 5 minutes to answer their doubt, okay? Yeah. See, your
since
doubt is why they have gone for blade. I hope I'm audible, everyone. I'm Prasad.
yeah, yeah.
Yeah. So I'll be taking your doubt, and then Vashil sir can continue. Okay. Your doubt is why Mahindra has gone for blade battery,
No, no,
or
no, no. I know why they have gone to blade battery since they are most easy to maintain that battery, and the pressure in the battery has uh, equally distributed, and it have the many advantages in the EVs.
yeah.
So they have using the. My concern was that.
Yeah, I'll just answer your concern. Just 1 minute. 1 minute. Is
Okay.
my slide visible to all
No, no.
now?
Yeah. Now, yes.
Yeah. Okay.
Yeah.
Now, actually, I'm going to tell you all this in detail. Okay. See, when you will use prismatic, no, that time,
Yes.
yeah, yeah.
Yes.
When you use
Not visible,
prismatic,
sir.
you have series parallel combination. Okay, your module will have series parallel combination. Okay, and then your
Yeah.
battery pack will be contained series. But
Yeah.
what
They have
Mahindra
like
is doing, yeah, what Mahindra is trying to do with this blade battery pack is they are trying to increase the voltage, keeping the parallel paths less.
yes.
That's what their fundamental is. That's what the Chinese companies are doing. They are trying to keep
Yes.
number of parallel path less, so that
Hmm.
the lesser current is drawn. Okay, fine.
Yes.
And why? Because if you take some internal resistance Rint of the battery, okay,
Mm-hmm.
so if there is more number of series path than the parallel path, the power loss, okay, will be lesser because the current is less in the series.
If there will be more, then the power loss will be more. If there will be less connection of the series and parallel, then there will be the like
Yes.
less losses.
Correct. So now, if you take only the same, see these two rating, you can see this. I'm going to explain shortly. Don't worry. In these two
Okay.
ratings, if you take the energy capacity of both batteries, same
Yeah.
energy wise, both batteries are same, but one operating at a lesser voltage, having more number of parallel path. One operating at a higher voltage, having less number of parallel path. Okay. What yes.
अरे प्लीज बताओ प्लीज यार.
Hello.
हेलो
Yeah,
हेलो
yes.
सर हिंदी में नहीं बता सकते, इंग्लिश समझ.
Is there any voltage drop in the battery?
Just I hope I hope your doubt is clear. I guess some disturbances there. I'll just check back. Yeah, any doubt someone was asking?
Hello.
Hi, yes.
Yeah, Prasad sir, actually they want to be आप थोड़ा सा हिंदी में बता दीजिए उनको ना, थोड़ा दूसरी तरह.
प्लीज सर हिंदी में बताइए हमको.
Okay. Santosh ji, correct? Yes. Generally, there are few international candidates also. That's why we are keeping it English. No issue. For you, I'll again explain in Hindi. Okay. I guess the doubt was originally किसका doubt था ये? Mr. Can you just tell your name? Hello.
Do you asking from me?
Okay. Fine, fine. Okay, I'll take up your doubt. I hope my screen is still visible. Just anyone from the tech team, just check what is causing a lot of disturbance when I'm talking. Yeah, okay now? Fine. Yes, so see, now there is always a tug of whether to go for high voltage or whether to go for high current. Means more number of parallel paths shall be used or more number of series models we should use. So Mahindra, which is actually taking the technology from the Chinese thing, so they are trying to have a more number of series path. Okay, so that's why they are trying to have more capacity in one cell only. More AH in one cell. Okay, and in blade battery, it can go up till 193 AH, 192 point something, that is 193 AH in one single cell. Correct? One single cell. Whereas in prismatic, what you are talking about is in one single cell, how much can be AH?
अरे भाई आपको हिंदी नहीं आती क्या यार?
ठीक है, ओके सुनिए, अगर आपके पास कोई बैटरी पैक है,
अच्छा
ठीक है, अगर आपके पास कोई बैटरी पैक है, ओके, अगर आपको दो बैटरी पैक दिया जाए सेम एनर्जी कंटेंट का, ठीक है, एक जिसमें आपका वोल्टेज कम है और पैरेलल पाथ ज्यादा है, ओके, और एक जिसमें आपका वोल्टेज ज्यादा है पैरेलल पाथ कम है, गॉट इट? ओके, तो यहाँ पे आपका क्या है कि यहाँ पे नंबर ऑफ सेल्स जो होंगे वो आपको सीरीज और पैरेलल दोनों रखने होंगे। अगर एक का नॉमिनल वोल्टेज 3.7 बोल रहा हूं मैं, तो कुछ सेल आपको सीरीज में लगेंगे, करेक्ट, टू मेकअप दैट, मतलब ये 48 वोल्ट बनाने के लिए आपको 13 सेल लगेंगे। अच्छा, समझा? करेक्ट,
दोनों ही
है ना? तो यहाँ पे आपका नंबर ऑफ पैरेलल पैथ ज्यादा लगेगा। तो ये मैं आपको थोड़ी देर में समझाने ही वाला हूँ, जस्ट एक का डाउट क्लियर करने के लिए मैंने स्लाइड दिखाया, ठीक है। आई होप जिसने डाउट पूछा था उसका डाउट क्लियर हो गया है। ओके, वाई महिंद्रा, मतलब महिंद्रा क्यों ये ब्लेड पैटर्न के पीछे लगा है?
हाँ सर, मेरा डाउट क्लियर हो गया।
थैंक यू
सर।
ओके, Vasheel, you can continue for your part, then I'll take over.
Yeah, thank you, sir. Okay. So my screen is visible, right? The screen visible है ना?
No, sir.
No, sir.
No, sir.
एक सेकेंड। Okay, अभी?
जी. Yes, sir.
Okay. So the next, why we are moving to blade है ना? Okay, just play this video. Okay.
चलो सर, आगे कुछ बताइए।
एक सेकेंड, सी ये है ना, अब one second, Santosh, just mute out. Some noise is coming. Wait.
ओके सर।
I will explain. Okay, mute कर दो. Okay. See, ये है ना nail penetration test. Okay, nail penetration test. Okay, इस पर हम क्या करते हैं, हम एक नेल को ओके आपका बैटरी पैर पर पेनिट्रेट करेगी, ओके, टू मेक इट शॉर्ट। तो शॉर्ट सर्किट क्रिएट करके बाद चेक कर देगा ये कैसा मैकेनिकली ये स्ट्रांग है, ओके, क्योंकि एक्सीडेंट और डिब्रीस आएगा, सो उसको पोक कर देगा, ओके, सो सम शॉर्ट आएगा, ओके, सो हम टेस्ट करते हैं कैसा ये बैटरी मैनेज कर देगा, ओके, सो यहाँ पर दोनों बैटरी को कंपेयर कर देगा, ओके। तो फर्स्ट है ना ये एनसीएम बैटरी, ये ना काइंड ऑफ प्रिज्मेटिक है, ये प्रिज्मेटिक है, ओके, बस प्रिज्मेटिक भी ये टेस्ट कर रहे हैं, ओके। सो आप सी कर रहे हो ये प्रिज्मेटिक है ना, वो बर्स्ट हो रहा है, ओके, ठीक है। और
ओके
अभी एक सेकेंड, अभी ब्लेड को हम जा रहे हैं, ओके, ये ब्लेड है, ओके, देख रहे हो क्या हो रहा है, कोई रिएक्शन नहीं है, ओके, कोई गैस लीकेज नहीं है, ओके, ये स्टेबल हो रहा है. ओके, देख रहे हैं ना, ये क्यों था? ओके, क्योंकि आपका ब्लेड है ना, वो आपका सर लेंथ है ना, वो बड़ा है. ओके, सो यहाँ पर शॉर्ट सर्किट होगा, ये हीट क्रिएट करेगा. ओके, ये हीट है ना, दिस हीट विल स्प्रेड. ओके, दिस विल स्प्रेड इट, which will reduce your maximum temperature on your surface. Okay, whereas in prismatic, एक संतोष आप आई थिंक तो प्रेजेंटेशन स्टॉप कर दो. आई थिंक आप स्क्रीन शेयर कर रहे हैं.
सॉरी सर.
ठीक है, ठीक है. सही, यहाँ पर भी शॉर्ट सर्किट हो रहा है. सही, कृष्णा, यहाँ पर भी शॉर्ट सर्किट हो रहा है. ओके, वो दोनों जगह पर सर्किट हो रहा है.
Sorry to interrupt you, sir. Your screen is not visible.
अच्छा,
It is visible, sir.
हाँ जी, just receive it. Okay, yeah. See, दोनों जगह पर भी शॉर्ट सर्किट हो रहा है. Okay,
Sir,
but
your screen is not visible.
Visible or not?
No, it is visible,
Not
but just
visible.
try searching
Visible,
it for
sir.
the screen.
Yeah, visible, sir.
Hey, just stop and start it again. Okay. Okay. Yes, think spin right. Think so. Yeah.
Yes, sir, it's visible.
Okay, visible, right? Okay.
Yes, sir.
Yes, sir.
See, वो दोनों जगह पर शॉर्ट सर्किट हुआ. ओके, बट उसका इम्पैक्ट है ना, वो अलग है. ओके, सो प्रिज्मेटिक है ना, यहाँ पर आपका शीट्स है ना, वो यहाँ पर स्टैक होगा. ओके, सो यहाँ पर है ना, there is less area for it to propagate. Okay, so when there is short circuit, heat will be generated. Okay, so this will accumulate and create your what we see. Okay, at the end, but आपका ब्लेड पर ये हीट है ना, वो स्प्रेड हो रहा है. ओके, ये हीट यहाँ पर स्प्रेड हो रहा है. ओके, क्योंकि आपका ये फ्लैट है. ओके, यहाँ पर शीट्स को बेंड नहीं कर दिया. ओके, पूरा फ्लैट है. ओके, यहाँ पर है ना, आपका थोड़ा बेंड होगा. ओके, आपका शीट को थोड़ा बेंड्स होगा. ओके, ये बेंड्स है ना, वो आपका शॉर्ट सर्किट को और बढ़ेगा. ओके, रेजिस्टेंस होगा बड़ा, और मोर रेजिस्टेंस होगा. ओके, so इसलिए आपका ब्लेड मोर सेफर है कंपेयर टू योर प्रिज्मेटिक. ओके, देन नेक्स्ट है ना आपका ये.
Hello.
Yeah.
Sir, can I ask question?
Yeah, Vishwadip.
Sir, can you come to the video? If you considering to the prismatic, the shape of the prismatic, the width of the prismatic battery is it means high as compared to the blade battery. So if we consider the nail test, we applying the force from top of the battery, means on the top of the prismatic battery. So there is no chances to bend, na sir, because the strength of the prismatic battery is the high as compared to the blade battery, na?
No, there is no factor of strength. Okay, I'm saying when you have short circuit, what happens? Current travel, right? Current will travel, right?
Yes, yes.
See, if there is a bend, means your resistance will increase. Electrical, you know, right? When there is an obstacle, its resistance will increase, right? It's not related to mechanical. This purely electrical. Okay.
Okay.
So this bend will create your more resistance, which will accumulate. Okay. See, there is no. It is like this. Your making of your prismatic. Okay. So आपको है ना, थोड़ा सा बेंड होगा स्टैक करने के लिए. ओके, वो शीट्स को बेंड करके स्टैक होगा प्रिज्मेटिक के अंदर. ओके, इफ यू ओपन अ प्रिज्मेटिक, इफ यू हैव चांस, ये शीट्स स्लाइटली बेंडेड. ओके, whereas in your blade this is flat. Okay, these are flat. I will show you if I will show the tear down of your blade. ब्लेड बैटरी को ओपन करके आप दिखाएगा, ये फ्लैट होगा. ओके, कोई बेंड नहीं होगा.
It means in the prismatic there is a area, the height of the area is huge, and the nail at the time of nail testing, the nail is contacting with the internal contents of the battery pack. So that's why there is a chances of the explosion as compared to the blade battery. the width of height of the battery is less, and the nail is directly applying the force and come outside the battery. So that's why there is no chances of the explosion, as you are saying.
और यू कैन से reiterated, ओके. क्या है ना, आपका प्रिज्मेटिक है ना, वो हीट डिसिपेट कर, वो हीट ट्रांसफर करने लिए कम जगह है, ओके. हीट जनरेट हो रहा है, उसको हम रिमूव करना है ना, वो ट्रैवल करना का पाथ है ना, वो बहुत डिफिकल्ट है. वरना आपका ब्लेड है ना, वो आसान है, वो स्प्रेड होने के लिए आसान है. इसलिए ना यहाँ पर हम देख रहे हो, ये बोल रहे हैं मैक्सिमम टेम्परेचर रीच्ड ओनली सीरीज. यू नो द पॉइंट, राइट? So the
Yes, yes.
temperature generated is been spread across your blade batteries, okay? Whereas in your prismatic, it can't able to do it, okay? The
Okay,
heat is
thank
not
you.
able to spread it, okay? Okay. Okay, guys. So then we move with your cell to pack and module free battery pack, okay? So the main difference क्या है ना, यहाँ पर हम modules use करते हो, okay? Each modules use करके ये stack करते हो, okay? From cell.
Hello.
Yeah.
Sorry to interrupt you. As you said in that blade battery, there is only one stack, battery stack, throughout the
No, there is
module.
no, there is not single stack. It will be multi-stack. Okay.
Okay. If the nail is going through the blade battery, then the nail is like a conductor, and there are multiple stack. When the nail is penetrating, then it will react with a different stack, same as through
Yeah,
the
that's what.
prismatic. So
Yes,
so
that's what.
so if we think there is a fire in the prismatic, then there should be the fire in the blade also.
See, should be fire, but the chances, I'm saying, okay,
Yeah.
the chances are less because heat is spread. If you take this blade battery, I want to put multiple nails in various points. It will get heat. Okay, but the chances, I'm saying, okay, the chances is less because of this factor that I mentioned. Okay, it's not like this. Yeah.
If the nail touches plus and minus of the pole,
yeah, short circuit will
then
happen. Short
there
circuit
should
will
be a short
happen.
circuit, and there should be the fire and heat spark.
Yes, that's what I'm saying. Heat is created, and here it is spreaded. Okay. Okay. But in prismatic, it can't able to spread it. Right.
All right.
Okay.
Okay.
Okay. Now, shall we move to the next one?
Sure.
Okay. See, next is your cell to pack and module free battery pack. Okay. So difference is that here from cell, I want to make module and I want to make your pack. Okay. Whereas in module free battery pack, I want to remove my module compartments. Okay. Which will save your less weight. आपका भी compartment में निकाल रहा हूँ, so उसका weight में remove कर दिया. Okay. We want to make this blade battery, उसका एक dimension ये length होगा. Okay. So we'll take the length, okay, as a dimension. So this would be like integrator path, kind of like if we take a box, wooden box. Now I just cut this wooden box, okay, and I stack them. So that is like your blade battery pack. So ये ना आपका battery pack का part होगा. Okay, it will be both integral with your battery pack. Okay, so this will be much more, can say, space efficient. You can able to utilize your space much more easily because यहाँ पर हमको each module compartment बनाना है. Okay, so उसके लिए हम मेटल sections को divide करेंगे. Okay, so उसके लिए space को हम utilize much नहीं कर सकते. Okay, so next ये आपका blade battery. First I just play this video. Okay, आपका blade battery का tear down. Okay, so ये आपका insulation. Okay, insulation है. So ये ना outside है ना aluminum plate से cover कर रहे हैं. Okay, ये आपका electrode है. Okay, okay, so ये है ना आपका thing. Can see, right? यहाँ पर coated, you can say like laminate coated aluminum and copper sheets. Okay, you can see, right? Wait. You can see here. Yeah, you can see यहाँ पर 26 groups है और 52 layers. Okay, so 26 groups of sheets. एक group है ना एनोड कैथोड और सेपरेटर. ओके, सो ये इसलिए ये है 26 ग्रुप्स आर स्टैक टुगेदर. ओके, ये वाला प्लेट बैटरी. ओके, सो यू कैन सी, सो दिस इज योर डायमेंशंस. ये आपका डायमेंशंस है. ओके, लेंथ अराउंड 960 mm. ओके, ये है ना आप यहाँ पर इसका ये है ना 13.5 mm और ये 90 mm. ओके, और ये है ना आपका टर्मिनल्स और ये है ना आपका गैस वेंट. ओके, सो गैस को ऑप्टिमाइज करने के लिए इफ गैस आर ऑप्टिमाइज मोर मींस दिस विल रिलीज इट लाइक अ प्रेशर रिलीफ वाल्व. ओके, हाँ, ओके, तो यहाँ पर देख रहे हैं ना, ये आपका शीट है और यहाँ से वो यहाँ पर इलेक्ट्रोड्स पर कनेक्ट कर देगा. ओके, सो ये है आपका स्पेसिफिकेशंस of your blade batteries. Okay, so this has the nominal voltage of 3.2. The capacity is around 138 Ah. Okay, around 138 Ah with the weight of 2.63 kgs. Okay, so the charging voltage is 3.65. Discharge minimum voltage, discharge cutoff voltage, which is minimum voltage, is 2 volt. Okay, so the distance is less than around 1.8 milliohms. Okay, and these are your temperature characteristics. Okay, so this is all about your blade battery pack. Okay, I think hope everyone is clear. So next processor will take about your battery pack of your Mahindra. Okay, which is purely made by your blade batteries. Okay.
Yeah, thank you, Vasheel. Yes, before I go ahead, see, I'll request everyone to note down the slide number. आप स्लाइड नंबर लिख लीजिए. ओके, जब मैं प्रेजेंट कर रहा हूँ कुछ डाउट होगा तो हम स्लाइड नंबर को रेफर करके पूरा कर देंगे. सो मेरी एक रिक्वेस्ट होगी, जस्ट लेट मी कंप्लीट माय प्रेजेंटेशन फर्स्ट. ओके, उसके बाद स्लाइड नंबर के हिसाब से यू कैन स्टार्ट आस्किंग डाउट. ओके, सो दैट अदर्स आर स्टिल कनेक्टेड टू अस. ओके, फाइन. सो क्या हो जाता है कि डाउट हम सॉल्व करने चालू हो जाते हैं, बट फिर वो क्या होता है कि 1 to 1 ऐसा लग रहा है, फिर बाकी लोग स्टे डिस्कनेक्टेड एंड ऑल. सो वी डोंट वांट दैट. So we want everyone to stay connected. So अगर कोई डाउट है आप स्लाइड नंबर लिख लीजिए. I'll solve your doubt. Don't worry. Yeah. अच्छा, मेरी स्लाइड विजिबल है. I hope my slide is visible. Okay. So here just before what Divyavani ma'am and Vasheel sir told you about this types of you can say form factors available, and the newest form factor, that is the blade battery pack, also you have seen. Now अभी यहाँ से हम क्या करने वाले, what we are going to do here is हम लोग पहले कैपेसिटी कैसे डिजाइन करते हैं, बैटरी पैक को कैसे डिजाइन किया जाता है वो सीखेंगे सिंपलेस्ट फॉर्म से. ओके, नाउ दिस इज व्हाट, एक बैटरी, 3 बैटरी से आपके, करेक्ट, सपोज. तो ये क्या इंडिकेटेड कर रहा है, व्हाट इज दिस कनेक्शन, आपके सामने भी है. व्हाट इज दिस टाइप ऑफ कनेक्शन, सीरीज कनेक्शन, +2 minus, plus of the next one, minus of the next one, correct? So you have total plus and total minus here, correct? Okay, so now batteries को या cells को हम जब series में करते हैं तो होता क्या है, what happens when we connect cells in series? If you check, the voltage get add up. Okay, अब ये 2 बैटरीज का एग्जांपल है. हर एक बैटरी कितने का, each battery is of 6 volt. 6 volt in series with 6 volt will become 12 volt. Okay, series addition, so it is 12 volt. This is plus, this is minus. Okay, but what about the ampere hour capacity? Ampere hour capacity, when you connect cells in series, the ampere hour capacity remains the same. Only what happens is voltage increases. Okay, so what happens in series combination, voltage gets add up, but total capacity remains same. That is the charge capacity. Okay, now what about the energy? जनरली एनर्जी वी टॉक इन टर्म्स ऑफ वर्क डन के हिसाब से वर्क डन इज वोल्टेज इनटू कैपेसिटी. नाउ हाउ मच इज द वोल्टेज? वोल्टेज कितना है हमारा टोटल? 12. ओके, एंड हाउ मच इज द एम्पियर आवर? 100 ampere hour. Correct. So can I say it is 1200 volt ampere hour, but your volt ampere stands for your watt. Okay, so can I say, क्या हम इसको ऐसा बोल सकते हैं 1200 watt hour 1.2 kilowatt hour. So what does it mean? जो एक बैटरी 6 वोल्ट और 100 एम्पियर आवर की थी, ओके फाइन, हमने क्या किया, हमने वोल्टेज बढ़ाया, कैपेसिटी सेम रखा और हमको एनर्जी कितना मिला? 1.2 किलोवाट आवर. गॉट इट? सीरीज करने से क्या हुआ? सिंपल, वोल्टेज बढ़ जाता है, कैपेसिटी रिमेन सेम. नाउ लेट्स गो अहेड फॉर 13 स्लाइड. नाउ ऑल आर इन पैरेलल, cells in parallel. Correct? All plus are connected together or minus are connected together, then one of it will form plus. Correct? And one will form as. Correct? Now अब देखो क्या हो गया, वही दो cells है, same cells are there, but now they are in connect parallel. So how much is the voltage? Total voltage? Total voltage कितना आया? 6 volt. Correct. Total voltage 6 volt. So voltage remains same during parallel. Obviously during parallel what? Voltage remains same. Correct. But what about capacity? The charge capacity will be added up. Correct. 100 ampere hour plus 100 ampere hour. It will be 200 ampere hour. Got it? Now मतलब क्या है, अगर मुझे एम्पियर आवर कैपेसिटी बढ़ानी है तो मुझे सेल्स को पैरेलल में करना है. अगर मुझे वोल्टेज बढ़ाना है तो मुझे सेल्स को सीरीज में करना है. ओके, सो अभी टोटल एनर्जी कितना आएगा? 6 इंटू 200 एम्पियर आवर कितना हो गया? अगेन द सेम वैल्यू आर गेटिंग, सेम वैल्यू आ रहा है. करेक्ट. सो दो वे हमने देखे 1.2 किलोवाट आवर बैटरी बनाने के, दो वेज. एक जो 6 वोल्ट पे काम करेगा, एक जो 12 वोल्ट पे काम करेगा. जो 12 वोल्ट पे काम करेगा, करेक्ट, उसको 100 एम्पियर आवर, मतलब उसका सी रेट कितना हो गया? 1C अगर भी बोलूं तो 100 एम्पियर आएगा. फॉर एग्जांपल इसमें अगर 1C भी बोलूं तो भी कितना आएगा? 100 एम्पियर करंट आपको लेना पड़ेगा. करेक्ट. इसमें 1C अगर बोलूं तो कितना एम्पियर ड्रॉ करना पड़ेगा? 200 एम्पियर. गॉट इट? समझ में आई बात? जो सी रेट है, करेक्ट, वो आपका जो कैपेसिटी है, करेक्ट, और आपको कितने आवर में वो बैटरी चार्ज करना है, 1 घंटे में बैटरी चार्ज करने के लिए कितना करंट लगेगा, हाउ मच करंट इट शुड ड्रॉ कंटिन्यूअसली टू चार्ज द बैटरी इन 1 आवर. करेक्ट. तो 1C मीन्स व्हाट? इफ 200 एम्पियर आवर इज द कैपेसिटी and within 1 hour you need to charge, that means you have to draw continuously 200 ampere current. Okay, if I say 2C, then it becomes 400 ampere hour. I want to charge the same battery within half an hour, so I need to draw 400 ampere hour. Getting the point? Clear? Okay. Yes. So now let's go ahead with one more simple example. Now each cell is how much? एक cell कितने का है? 3.6 volt का है नॉमिनल वोल्टेज एंड 3400 mAh का है, मिली एम्पियर आवर, विच कैन सिंपली बी रिटन फॉर सिंप्लिसिटी 3.4 एम्पियर आवर. ओके, नाउ मेरा जरूरत क्या है? आई वांट 6.8 एम्पियर आवर और 6800 मिली एम्पियर आवर, और मुझे वोल्टेज चाहिए 7.2. टोटल वोल्टेज कितना चाहिए? टोटल 7.2 वोल्ट. टोटल कैपेसिटी 6.8 एम्पियर. क्या करना पड़ा मुझे? व्हाट आई हैव टू डू? पहले मैं एम्पियर कैपेसिटी बढ़ाने का सोचूंगा. तो मुझे अगर एम्पियर कैपेसिटी बढ़ाना तो मुझे क्या करना पड़ेगा? पैरेलल. करेक्ट. सो नंबर ऑफ पैरेलल पाथ कितने आए? आई वांट 6.8 एम्पियर आवर, हर एक का 3.4 एम्पियर आवर कैपेसिटी है, तो कितने पैरेलल पाथ है? 2. Number of 2 parallel paths. Now total voltage कितना चाहिए था? 7.2. So total voltage required was 7.2, correct? And I want voltage of each cell is 3.6, correct? So what is the number of cells in series? Number of series combination. That is 7.2 divided by 3.6, again 2. So what does it mean? First, I'll make a parallel combination, increase the capacity, then I'll add such combinations in series, correct? First, then second, I'll add such combination in series to get my total voltage. This is how in bigger battery pack it is done. First, the ampere hour capacity is decided, number of parallel paths for that is decided, correct? And then we add such module in series. Clear? Now, yeah. So if you say from one cell, if it's a cylindrical type, one cell we get module. From module we are going for battery pack. Okay. Fine. Now let us again discuss this MS and NP structure. Okay, and let us try to figure out which is more advantageous. Okay. Now here one cell capacity is how much? One cell, each cell voltage is
6 volt.
3.7 volt. Okay, and charge capacity is, can I say 3.4 ampere hour? Clear? Okay, now I want, let us say for the first category, this category battery, wherein the voltage is less number of series path, but the ampere hour capacity is more. Clear? Okay, now for total cells in series, what I have to do for total cells in series? Voltage required, correct? Voltage required, 48 volt required, divided by voltage of each cell. Voltage required, that's what I have done na? In previous slide check. In previous slide, that's what I have done. Voltage required, correct? Voltage required divided by voltage of each cell. Okay, so same way here, हमें क्या करना है? Voltage required 48 divided by voltage of each cell. कितने cells आएंगे? Approximately how many? 13. Am I right? 13 cells in series आ जाएंगे. बट 13 सेल्स इन सीरीज आएंगे क्या? नहीं, 13 मॉड्यूल्स आप बोल सकते हैं, 13 पैक ऐसे आप बोल सकते हैं, करेक्ट? अब 13 कॉम्बिनेशन, एक कॉम्बिनेशन में क्या आएगा? कितने पैरेलल सेल आएंगे? तो वो जानने के लिए क्या करना पड़ेगा? मुझे कितना चाहिए? 100 एम्पीयर आवर. सो टोटल कैपेसिटी डिवाइड बाय कैपेसिटी ऑफ ईच सेल. टोटल कैपेसिटी डिवाइड बाय कैपेसिटी ऑफ ईच सेल. कितना है कैपेसिटी ऑफ ईच सेल? 3.4. कितना आ रहा है? चेक कीजिए. 100 divided by 3.4. Yes, anyone? Divided by 3.4. Almost 30.
29.
29.4 something. So approximately I am taking 30 cells in parallel. Correct? Okay, so 30 cells in parallel. Total number of cells कितने हो जाएंगे? Means there are 30, I'll say. Means there are a bunch of 30 cells, 1, 2 like this. How many? 30 cells, correct? And such 30 cells, there is a bunch of 13 such cells, correct? Okay, so total number of cells is 13 into 30, that is 390 cells. Okay, and this category we call it as what? 13S, correct? And 30p. So this battery pack will have what? 13S, 30p. Now how much will be total energy of the battery? Total energy we want 4.8 kilowatt hour. How, sir? Simple, V into Q. Expected is what? 4.8 kilowatt hour. How much you will get? Simple, just since you have 13 cells, total voltage is how much? Total voltage, exact voltage, 13 into 3.7. How much you are getting? 13 into 3.7. 48.1.
48.1.
Correct. So 48.1 And how much is total capacity you are getting, total charge you are getting? That is 3.4 into 30. So how much? 3.4 into 30. 102?
Yes, 102.
102 ampere.
Yes.
102 ampere. So what is the total energy? Total energy for this 48 volt 100 ampere battery, exact 48.1 into 102. Correct?
4896.
Yeah, 4906.
Yes.
Correct. So that means 4.9 kilowatt hour battery you got. Okay. And you're expecting what? 4.8 kilowatt hour battery. No problem. Energy is almost how much? 4.9 kilowatt hour. Understood this? 13S, 30P. Okay. Now, how much is the current drawn at 1C? 1C rate. Since it's a 100 ampere hour, correct? Okay. You have total capacity 102 ampere hour. So to charge within 1 hour, it should take 102 ampere current accurately. Current drawn at 1C is how much? 102. How I got to know? Total capacity in ampere hour at 1C means what? Within 1 hour, how much current it should take continuously to charge the complete battery. That is 1C. Okay, so 102 ampere. Now, if I take internal resistance of the battery overall, not battery, complete pack, if I take it to be 0.1, suppose 0.1 or 0.01. So how much is the power loss? 102 square into 0.01. How much? 102 square. Correct. Fine. Into 0.01. 104. Is it correct? Yes. 104.04 watt. Watt. Okay, this much is what your, this much is your power loss in 1 hour. 104 watt. Okay. Now let us go for this battery. Let us check what happens here. Now number of cells in series. I want for 480 volt and 3.7. Don't you think it will be exactly 130 cells in series? 130 packet series? Correct? Fine. 130 in series. Simple. 480 divided by 3.7. Only 10 is here. So 10 will add up here. 130. Now how many cells in parallel? I want 10 ampere hour. Correct? 10 ampere hour. So 10 divided by 3.4. Approximately how much? 3. Means what? How the pack will look like? 3 in parallel to have 10 ampere hour and 130 such strings to get a complete 480 volt 10 ampere hour battery. Okay, again number of cells required is 390 cells. Now what is the MSNP structure? 130S and 3P. Correct? 130S, 3P. Total energy again. How much is total energy? For that, I have to check total voltage. TVL, right? Total voltage is 130 cells into 3.7. How much it will come out to be? 481. Correct. Just one decimal. Correct here.
Correct.
Fine. 481 volt. And total charge 10.2 ampere hour. It is 3.4 into 3, 10.2 ampere hour. So how much energy you are getting again? Is it same? 4.9 kilowatt hour. So both the batteries are giving same energy. But what's the difference? One working at a high voltage and lesser current, and other working at lesser
Lower
voltage.
voltage.
Yeah. Okay. So now what is the ampere hour here? 1C rate required for this battery. 1C rate required for this battery. Anyone? Answer is very simple in front of you. How much current it should draw continuously for 1 hour? Is it correct?
Correct.
Yeah. Now 10.2 square into 0.01. How much it will be?
104.
10.2 square into 0.01. Into 0.01 is remaining. So 1.04. So which battery pack you will prefer? Which battery pack you will prefer? First, type 1.
Type 2.
Type 2 you will prefer, correct. Type 2 you will prefer. Okay, so the C rate is not a burden for me. Correct. The power loss is minimized by having more number of series module. That's what your Mahindra is trying by doing that, copying that DIYguru battery. Okay, taking number of cells in series. In fact, you will be shocked that only means all are in series. All cells are in series. That's what we are going to discuss now.
Yes.
Okay, so this is one small video because see क्या होता है कि कई सारे लोग क्या है नए जुड़े हैं, उनको ये नया फर्स्ट टाइमर है वो, तो इसके लिए बेसिक वाला भी पार्ट है और एडवांस वाला भी पार्ट है. तो ये एक वीडियो है जहाँ पे सेल्स से आपका मॉड्यूल कैसे बनता है, मॉड्यूल से बैटरी पैक कैसे बनता है वो दिखा है. तो जस्ट रिक्वेस्ट गो थ्रू इट, उसके बाद लगे तो हम महिंद्रा वाली बैटरी पे चालू करेंगे आगे. There is no volume for this, just you have to observe. Okay. Fine. Correct. This is cell number. From this you can get a data. How much ampere hour capacity it is. Nominal voltage is 3.7. So these are cell guards. Very important. Because when you're doing spot welding, ये cell guard होते हैं.
Yes, sir. Cell sleeve होता है.
हाँ, cell guard.
Yes, yes.
Yeah. तो ये cell guard क्या करता है कि जब आप spot weld करते हैं ना, तो आउटर साइड पे इलेक्ट्रोड्स रहते हैं. जनरली अगर आप लिथियम आयन सेल देखेंगे ना, तो आउटर इस पे आपका इलेक्ट्रोड्स रहते हैं. तो वो डैमेज ना हो इसके लिए वो गार्ड है, ताकि स्पॉट वेल्डिंग करते वक्त उनको डैमेज ना हो. ये आपके सेल स्पेसर, सेल होल्डर्स बोलते हैं. करेक्ट. जैसा आपको कितना एम और कितना पी चाहिए, हाउ मच एम और हाउ मच एस एंड हाउ मच पी चाहिए, उस हिसाब से हमको कनेक्ट करना है. करेक्ट. ऐसे जोड़ते हैं. Fine. Okay, have you counted how many things are there? How many rows, column, whatever you say. Rows, चलो इसको बोलते हैं rows. How many rows are there? 10 rows are there?
10 rows.
10 rows are there. And how many columns are there?
6.
6. Correct. Okay. So let's see how much P and how much S is there. Okay. Yeah, they are showing similar thing will be required. They are making 2 modules and 1 battery pack from the 2 module. 2 module बना रहे, 2 battery, एक battery pack बना रहे 2 module से. हाँ, now check. Okay.
Polarity change करा, positive negative.
हाँ, yes. मतलब ये क्या होने वाले हैं? ये सीरीज में आने वाले.
Negative.
सीरीज में आने वाले. Yes. करेक्ट. तो कितना S हो गया ये? मतलब ये जो 10, या दिस विल बी 10s. Am I right?
Right.
10s. अब एक पोलैरिटी मतलब वो पैरेलल.
Yes.
करेक्ट. तो 6 in parallel. तो कैन आई से इट इज 10s 6p?
Yes, sir. 10s 6p.
10x 6p. Correct. Okay. ओके. यस. अभी ये कनेक्टेड हो गया क्या? नहीं, खाली आपने प्लेस किया है.
Just place है.
जस्ट प्लेस. अभी देयर इज अ निकल स्ट्रिप. ओके, निकल स्ट्रिप लगेगा हमको. जो निकल स्ट्रिप क्या करेगा, पहले तो इन सबको पैरेलल में कनेक्ट करेगा. ऑल विल बी इन पैरेलल. ओके, इसको भी पैरेलल में. बस इनके बीच में एक लिंक रहेगा. अब वो लिंक आप 10 जगह डालो, 6 जगह डालो, या एक ही लिंक डालो, देन ऑल्सो ऑल विल बी इन सीरीज ओनली. एम आई राइट?
Right.
What I mean to say is, देखो ये कितने सेल है? 6. तो 6 cells in parallel, is it visible?
Yes,
Is
sir.
my
Visible.
diagram visible? Yes. 6 cells in parallel, correct?
Correct.
Now after these 6 cells are in parallel, okay, I can have one strip and again another 6 in parallel, correct? Correct? Another 6 in parallel, correct?
Correct.
Yes. So I can have one link here or I can have many links here. Does it matter? Does it matter?
No.
No. So what's the difference? एक लिंक से क्या होगा? इसका करंट कैपेसिटी ज्यादा होगा, मतलब इसका ज्यादा होना चाहिए. एक ही लिंक रखेंगे तो, डिस्ट्रीब्यूटेड रखेंगे तो करंट विल बी डिस्ट्रीब्यूटेड इक्वली, करेक्ट? Anyhow, this pack and this will be in series only because of this link. एक बनाओ या 6 बनाओ, they complete this module and this module will be in series only. कितने लोग को ये समझा? तो हम आगे बढ़ते हैं, बराबर?
Correct.
Yes. अभी वही इन लोग by placing nickel strip वही करेंगे. देखो, now they will place a nickel strip.
जैसे नीचे था वैसे ऊपर करेंगे.
यस, जैसे नीचे था वैसे ऊपर. यस. अब ये बन गया आपका एक मॉड्यूल, 2 मॉड्यूल बन गए. अब निकल स्ट्रिप दिखाएंगे वो, या 2 मॉड्यूल बन गए, अभी निकल स्ट्रिप दिखाएंगे. ओके. ये स्पॉट वेल्डिंग मशीन है, करेक्ट? अब बहुत सारे ऑब्वियसली ब्रांडेड कंपनीज में क्या होगा, you will not require this machine, it will be a robotic welding, correct?
Correct.
Fine.
लाइक एट अ टाइम पूरे ग्रिड को एक साथ कर देगा.
हाँ, यस. अभी आप स्पॉट वेल्डिंग करेंगे, ये देखो. हाँ, अब क्या हो गया? हाँ, अब क्या हो गया? चेक. एक स्ट्रिप से, ये एक जो स्ट्रिप है ये सेपरेट भी आता है, मतलब एक ऐसा सिंगल स्ट्रिप भी आएगा.
भी आता है. ओके.
हाँ, सिंगल भी आएगा या ऐसे भी मिलेगा मार्केट में. आपको
2P होगा आई थिंक.
यस,
ये 2P है.
कौन सा? नहीं नहीं नहीं, ये वही है बैटरी आपका. कितना? 1 2 3 4 5 6 6P, करेक्ट? 6P और 10S ही है ये.
ओके.
है ना? देखो क्या करना है आपको, सिंपल इधर ध्यान देना है कि सेम पोलैरिटी वाले कितने सेल्स है. सेम पोलैरिटी वाले 6 सेल्स है.
ठीक है सर.
हाँ, तो ये 6P हो गया, करेक्ट? अपोजिट पोलैरिटी वाले कितने हैं? 10 है, तो 10S हो गया. ओके, ठीक है. अब ये क्या हो गया? ये एक स्ट्रिप क्या कर रहा है? ये जो पूरा नेगेटिव है, ये नेगेटिव टर्मिनल है, करेक्ट? ये नेगेटिव टर्मिनल, ये एक स्ट्रिप पूरे नेगेटिव को एक साथ कर रहा है. जैसे कि यहाँ पे एक स्ट्रिप, ये वाला स्ट्रिप है, वो एक स्ट्रिप पूरे नेगेटिव को एक साथ कर रहा है. समझी बात? ओके. यस, चेक है ना? यस. तो ये स्पॉट वेल्डिंग चल रहा है. ओके, आफ्टर स्पॉट वेल्डिंग इज कंप्लीटेड, अभी क्या हो गया? यस, वेट.
will do it.
Yeah, weld is done. Yes. Now wait and watch. Say, now let us say this is my you can say yeah, this is my bottom part actually. Bottom part. This may be my top part below. Okay, this is the bottom part. So there will be one line, one strip only where you will not find like this. That will actually act like your plus of the battery. Let's check whether it is visible here in this video or not. Here, see, they have shown. See, can you see this? Single strip connected to all plus.
Yes, this is.
Yes. So from here to here, correct? From here to here, that will be your one module. Okay, correct? And they are joining those two modules together. 10. Check 10S. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, so that's what they are shown here. So this is one module, 10s. Okay, I'll draw like this. See, 10s. Okay, now they have connected the plus of the next module with this. So this is the minus of the previous module. This is the plus of the next module. And again, now this will be the minus of the next module. So check at the end, if you have one module or two module, at the end, you will have one single strip for all the plus and you will have one single strip for all the minus. Got it? Yes?
Got it.
Okay. Yeah. Now, is this a complete arrangement? No. Similar things will be there at the back. At the back. This is the top side, suppose. So bottom will also have such kind of things. Where it will be? From this row and this row, at the back side, there will be connections, strips. Getting the point? समझा? ये जो है, ये एक पैरेलल पाथ है, ये एक पैरेलल पाथ है. मतलब ये प्लस गया, प्लस से गया माइनस जो नीचे वाले पार्ट में आ गया, इसके पीछे. करेक्ट. अब इसके बाद आपका यहाँ पे प्लस है, नीचे प्लस है और ऊपर माइनस लेके आया. ये माइनस है, ये सब माइनस है. करेक्ट है ना? तो ये दोनों को जोड़ना भी जरूरी है. करेक्ट.
यस सर.
हाँ, तो इसके लिए ऐसे स्ट्रिप नीचे भी होंगे. ऐसे स्ट्रिप नीचे भी होंगे, मतलब एक नीचे साइड, एक ऊपर साइड.
अल्टरनेट होंगे ना?
हाँ, अल्टरनेट. करेक्ट. तो नीचे साइड आपका ये कनेक्ट हो जाएगा, ऊपर साइड से ये कनेक्ट हो गया, फिर से नीचे साइड से ये वाले रो कनेक्ट होंगे. गॉट द पॉइंट? यस.
Yes, got it.
यस.
Yes, sir. Yes, sir.
यस. ये हो गया आपका एक बैटरी पूरा पैक हो गया. एक मॉड्यूल, दो मॉड्यूल बनाए उन्होंने 10s 6p के. करेक्ट. ना अगर ये क्लियर है तो हम आगे बड़े बैटरी पैक के लिए जाते हैं. दिस इज द महिंद्रा बैटरी पैक. करेक्ट. अब इससे भी ये सिंपलेस्ट क्यों है? बिकॉज इसमें जो भी ब्लेड केमिस्ट्री अभी वशील सर ने आपको बताया वो सभी सीरीज में ही है.
Yes, so parallel series का combination less है.
ये है इसमें.
हाँ,
इसमें नहीं है.
इसमें नहीं है. Only
इसमें नहीं है.
series है.
यस, करेक्ट. और वो क्यों रखा होगा? किसको क्या लगता है आपको ये सब सीरीज में क्यों?
तो कॉम्प्लेक्सिटी कम करना है प्लस अपना वो वोल्टेज इंक्रीज करना है.
वोल्टेज इंक्रीज करना है ताकि सी रेट आपका जो है 1 सी रेट भी अगर बोलूं तो जो करंट लगता है 1 सी रेट के लिए वो कम रहे.
यस.
गॉट इट. इसके लिए ये सब है. ओके. अब ये टारगेट क्या है? ये बैटरी पैक में 8 मॉड्यूल्स है. 1 2 3 4 5 6 7 8 मॉड्यूल. तो आपने एक मॉड्यूल देखा आपने, बट वो क्या था? सिलेंड्रिकल का था. अभी जो आपका ये मॉड्यूल बना है वो बना है ब्लेड बैटरी से. ओके. तो ये आपका एक बैटरी पैक हो गया महिंद्रा का बी का. ओके. जिसमें एक मॉड्यूल में 16 सेल्स आते हैं, ब्लेड LFP.
यस.
हाउ मेनी सेल्स? 16 सेल. 16 सेल्स. तो एक मॉड्यूल में 16 और टोटल 8 मॉड्यूल्स. टोटल सेल्स कितने हो जाएंगे? 128. तो 128 सेल्स है हमारे पास. करेक्ट. 128 ब्लेड LFP सेल्स है. करेक्ट. अब मुझे चाहिए कितना कैपेसिटी?
79 किलोवाट.
यस, 79 किलोवाट. अगर मैं डिसाइड करता हूं कि इसको 400 पे चाहिए, मुझे 400 वोल्ट पे इसको मुझे चार्ज करना है, ये बैटरी को 400 वोल्ट पे चार्ज करना है, तो व्हाट शुड बी द कैपेसिटी ऑफ ईच सेल? एक सेल का कैपेसिटी कितना होना चाहिए? तो लेट अस सिंपली से दैट माय कैपेसिटी रिक्वायर्ड, total capacity, I'll say total capacity required is total energy required. Total energy कितना है? 79,000 watt hour. Yes, 79 kilowatt hour means 79,000 watt hour divided by वोल्टेज मैं चाहता हूं बैटरी का, मैं चाहता हूं 400 वोल्ट रहे. कितना? 400 वोल्ट. ओके. सो अभी कितने सेल्स लगेंगे आपको चेक करो. So it is Q equal to, simple formula, Q equal to W by, or you can say energy by voltage. Okay, so how much is the capacity required?
197.3.
79,000 divided by 400.
197.5.
197.5. So can I say approximately 198 एम्पियर आवर का कैपेसिटी एक सेल का चाहिए मुझे, जो कि
Yes.
आपको ब्लेड स्ट्रक्चर दे पा रहा है। क्यों? बिकॉज ऑफ द वॉल्यूम इट इज हैविंग। करेक्ट?
सॉरी सर,
यस
सर एक बार थ्योरी फिर से
हाँ,
बोल
नो
सकते हैं?
प्रॉब्लम। सी, आपका कितना किलोवाट आवर का बैटरी पैक है? 79 किलोवाट आवर का बैटरी पैक है। ये कहाँ से आया? इसका डिजाइनिंग अगर सीखना है तो हमको नेक्स्ट इसमें देखना पड़ेगा कि रेंज पहले डिसाइड होगा, कितना किलोमीटर आपका गाड़ी जाएगा, आपका बैटरी पैक का कैसा सेल का मॉडलिंग करना पड़ेगा, फिर हर किलोमीटर में कितना वैट आवर कंज्यूम होगा वो कैलकुलेट करना पड़ेगा। उस हिसाब से मुझे बैटरी पैक डिसाइड करना पड़ेगा। फिर से बोलता हूँ, पहले रेंज डिसाइड होता है, कितना रेंज जाना चाहिए, फिर आपका चूजन सेल के हिसाब से, सेल मॉडल के हिसाब से एक वैट आवर में कितना किलोमीटर जा पाएगा आपका गाड़ी, वो डिसाइड होगा। उसके बाद आपका ये बैटरी पैक डिसाइड होगा। ओके, कितना 79 किलोवाट आवर का। तो अभी यहाँ पे हम लोग डायरेक्टली क्या बोल रहे हैं कि 79 किलोवाट आवर का बैटरी पैक है। ओके, तो 79,000 वैट आवर हो गया। मुझे इसको 400 वोल्ट पे रखना है, बैटरी को 400 वोल्ट पे रखना है टोटल, ऑल सीरीज कॉम्बिनेशन मिलके 400 वोल्ट। तो 79,000 डिवाइड बाय 400, कितना कैपेसिटी आया? 198। तो ये
198
हाँ, तो ये 198 पूरे का है।
yes
पूरे
over
ओवरऑल। बट आपने देखा ना, टोटल सीरीज है ये सब, 128 सीरीज सेल है।
yes
128 सीरीज सेल। सो मतलब सीरीज में कैपेसिटी क्या होता है?
सीरीज में वोल्टेज इंक्रीज होगा obviously.
हाँ, कैपेसिटी क्या होगा? इसके लिए हम लोग को फिर ये वाले स्लाइड पे वापस
कैपेसिटी सेम रहेगी।
हाँ, करेक्ट। सीरीज में वोल्टेज बढ़ेगा बट कैपेसिटी सेम रहेगी। तो जो आपका एक्सपेक्टेड कैपेसिटी है वो हर एक सेल से आना चाहिए। करेक्ट, आपका सेल का कैपेसिटी हर एक सेल का इतना होना चाहिए, 198 एम्पियर आवर का होना चाहिए। वही इसलिए उन्होंने ब्लेड एलएफपी दिया है।
हेलो सर।
हाँ, यस, बोलिए
सर, which type of cell we are use? Air prismatic cell or either cylindrical cell?
ब्लेड
Also blade.
LFP type I think.
Yes,
सर ये LFP पाउच सेल है क्या है ये? What they are using the blade is?
It's a blade capacity.
Blade cell.
ब्लेड सेल।
No, blade cell
इसलिए
correct
हमने
means
ये
pouch form correct?
नहीं, सी, इसीलिए हमने, अगर आपने देखा रहेगा, हमने ये वेबिनार कैसे रखा है, पहले एक सिंपलिसिटी, सिंपल सेल फॉर्म फैक्टर्स क्या होता है अलग अलग, फिर ब्लेड सेल फैक्टर क्या होता है, सेल फॉर्म फैक्टर क्या होता है, वो समझाया वशील सर ने। उसके बाद हम लोग ये ले रहे हैं। तो ये पाउच नहीं है, ना ही सिलेंड्रिकल है, ना ही प्रिज्मेटिक है।
एक्चुअली ये prismatic ही है।
डिवाइडिंग में यूज किया हुआ ब्लेड एलएफपी है। ओके,
So we can consider it as prismatic cell, like blade cell.
see, prismatic, you need more parallel paths. Again, I'm telling you, because one prismatic cell, can you build up of this 198 ampere hour? Check. You can find out.
So can you just explain once
I'm
again,
asking you.
like how the blade?
We find one prismatic
battery is
cell of
formed.
198 ampere hour.
सर prismatic में 200 AH we are using no sir? Prismatic cell में 200 AH का आता है LFP में।
How much voltage?
3.2 वोल्ट में
3.2
3.2 पे
3.2.
Yes.
Can we place at a flat thing?
Yeah, the space
Yes.
you can definitely in blade is
Correct.
better. Yeah.
Correct. Yeah. So see, they might have designed this thinking something in mind. Now, always pros and cons are always there for each battery model. But now, you know what?
Right.
One more thing I'll like to clarify in detail. When Mr. Vasheel will take up that thermal management, prismatic cell, you know, one problem is of thermal management. If you have really looked at the slides which each of our colleague have discussed, no, it's really having, you can see proper, see this, costly thermal management for prismatic.
Yes, correct.
Correct. So this, if you now give us some time and let us explain how the thermal management is done in this B battery, Mahindra battery, you will get to know why they have used this structure. मैं वही बोल रहा हूँ, थोड़ा पेशेंस रखिए, आपको सब आंसर्स मिल जाएंगे। थोड़ा पेशेंस कि इसमें कोरिगेटेड ट्यूब्स होते हैं, थर्मल बॉन्डिंग होता है, जिससे वो आपका बैटरी का टेम्परेचर
कूलिंग करके रखता है।
यस। तो ये प्रिज्मेटिक में डिफिकल्ट हो जाता है। करेक्ट, प्रिज्मेटिक में डिफिकल्ट हो जाएगा, इसीलिए हम लोग ब्लेड एलएफपी में वो पॉसिबल है। और कैसे पॉसिबल?
सीरीज पैरेलल का कॉम्बिनेशन भी कम हो जाएगा ना,
कम हो जाएगा। करेक्ट है। सब सीरीज में ही है, पैरेलल तो है ही नहीं इसमें। सब सीरीज
नहीं
यस। तो अभी जो थर्मल का बात है ना, उसको पकड़े रहिए, वो आपको बराबर 10-15 मिनट में क्लियर हो जाएगा। मेरा मतलब मेरे कलीग है वशील, ही विल अगेन टेक अप एंड डील विद द थर्मल पार्ट ऑफ इट। ओके, लेट्स गो अहेड। अभी ये समझ में आया आपको बैटरी पैक बी का? ओके, तो ये आपका स्ट्रक्चरल मेंबर, 4 स्ट्रक्चरल मेंबर है ऐसे खाली, मतलब विदाउट बैटरी पैक दिखा रहे हैं पूरा जो केसिंग है। ओके फाइन। ओके, 8 beams are there. These are the 8 beams, correct, and there is one longitudinal member. This is a longitudinal member. Okay, अब यहाँ पे ना ये जो है हर एक जो आपका ये होगा मॉड्यूल, हर मॉड्यूल के साथ एक बैटरी मैनेजमेंट सिस्टम होगा, बीएमएस।
बीएमएस होगा, इंडिविजुअल बैटरी
होगा। तो ऐसे 8 बीएमएस होंगे जिसको हम बोलेंगे स्लेव बीएमएस। और
स्लेव बीएमएस होगा,
या स्लेव बीएमएस इधर यही आगे है वो स्लाइड। हर एक इसमें आपका क्या होगा, ये जस्ट फ्रेम है, ये जस्ट फ्रेम है जिसमें आप अपना मॉड्यूल रखेंगे। ओके, उस फ्रेम के अलावा भी आपको बाहर एक एक्स्ट्रा फ्रेम लग रहा है ना, ये किस लिए लग रहा है? आपके कॉन्टैक्टर के लिए, नेगेटिव कॉन्टैक्टर यूनिट के लिए, और एक आपके मास्टर बीएमएस के लिए, और प्रेशर रिलीफ वेंट। अब ये प्रेशर रिलीफ वेंट भी कब, जब आप कूलिंग का पार्ट सीखेंगे तब वहां पे देखना एक प्रेशर रिलीफ वेंट भी होगा। ओके,
एआरवी होगा।
यस। अब ये रहा आपका, ये जो एक दिख रहा है आपको, ये लॉन्ग एकदम, दैट इज योर ब्लेड एलएफपी।
Yes, the blade LFP.
ब्लेड एलएफपी ये वाला एक। तो इफ यू चेक हाउ मेनी आर देयर, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 and 16. Correct? 16. Okay, so this 16 will be placed in one tray here. This 16 will be placed here, complete one module. Got it? Okay. तो yes, अब इसमें भी क्या है, ये प्लस है, इसका माइनस कहाँ होगा? बैक साइड। ओके, और ये कौन है फिर ये माइनस ऑफ द सेकेंड वन।
Yes.
माइनस ऑफ द सेकेंड वन, प्लस ऑफ द फर्स्ट वन, माइनस एट द रियर साइड, प्लस ऑफ दिस इज एट द रियर साइड, एंड दिस इज द माइनस वन। सो लेट अस से ये जो मार्क है वो माइनस है, टर्मिनल इज द नेगेटिव टर्मिनल ऑफ दैट बैटरी।
ओके,
करेक्ट।
सर एक मॉड्यूल आके 48 वोल्ट्स करेगा, लगभग 3.2 वोल्ट है ना इसका मिनिमम ब्लेड का।
एलएफपी में सभी सेल का वोल्टेज 3.2 ही रहेगा।
यस,
ब्लेड का
ये बढ़ गया,
3.2 into 16 करना पड़ेगा आपको।
16 का 48 वोल्ट आएगा आपको, 52
करेक्ट।
So each model is around 52 वोल्ट के करीब आएगा।
यस, करेक्ट। सिंपल 3 पॉइंट, आपका जो 3.2 नॉमिनल वोल्टेज है ना इधर, करेक्ट।
यस,
है ना?
जी बिल्कुल
फाइन। वो मल्टीप्लाई बाय आपका 16 आ जाएगा, सीरीज है ना, 16 इन सीरीज, करेक्ट।
51 वोल्ट।
फाइन, यस, यहाँ पे एक
51.2।
यस, 3.2 into 16 करोगे तो आपको एक मॉड्यूल का या एक मॉड्यूल का वोल्टेज आएगा, है ना? ओके, अब यहाँ पे देखिए, ये जो प्लस है उसका एक कनेक्टर सिंगल है, सिंगल, जस्ट लाइक प्रीवियस बताया ना, ये सिंगल है इधर। ये इंसुलेशन प्लेट है, ये वाला ब्लैक वाला इंसुलेशन प्लेट है, इसको हम बस बार बोल रहे हैं। तो ये पॉजिटिव इस पे आ जाएगा, ये स्लॉट में, करेक्ट। ये जो स्लॉट दिख रहा है आपको, ये स्लॉट में ये वाला आ जाएगा, और वो इसके साथ पॉजिटिव के साथ कनेक्ट होगा। फिर ये दोनों को क्या करना पड़ेगा? इंटरकनेक्ट करना पड़ेगा स्पॉट वेल्ड से, स्पॉट वेल्ड से। तो ये स्पॉट वेल्ड यहाँ पे हो जाएंगे।
ये लेजर वेल्ड होगा ना सर?
हाँ, यस, करेक्ट। रोबोटिक वेल्डिंग हो जाएगा, करेक्ट। और मतलब क्या होगा, ये दोनों जो ये माइनस है,
प्लस और माइनस
प्लस है, वो कनेक्ट हो जाएंगे।
यस।
तो ऐसे ही करते करते आपका पूरा सीरीज बन जाएगा। दिस विल बिकम सीरीज एंड द लास्ट वन इज नेगेटिव।
Which type of material we are used here, sir?
Yes.
Material, which type of material we are used? This type of plates.
These are aluminum.
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 So this bus bar is copper or aluminum?
Which one? Generally,
bus bar what they are using?
Expected is nickel.
Nickel, yes sir.
Nickel. Correct. Expected is nickel. Yes. Okay. Now, see, I hope you got how to connect this in series. Yes. Now this much is not enough. Any manufacturer can't sell its battery without BMS. Okay, it can't
sir.
sell its battery without BMS. So this is the structure. Whatever you are looking at is the BMS.
Hello, sir.
Fine.
Okay.
Now, how many? Yeah, how many series connections you saw? 16, na?
16.
Yes.
So it is like this, 16 in series.
Yes, yes, 16.
Correct. Okay. So let us. I'll give some example. Let us say 4 cells are in series. How much?
Okay.
4
4
cells
cells.
are in series. Okay. Maybe for okay, I'll again say. Let us say these two are in parallel. So can I say it is 4s2p?
Yes, yes.
Correct. Why I'm telling you? Because it will be utilized for other battery pack also, not only this battery pack. For other battery pack also, you can remember this. Now think of the voltage level. This is the 0 voltage level or the negative of the battery, complete battery. Correct. And this is the positive. Positive. Okay. Now each cell, suppose it is of 3.7 volt. So how much is the total voltage level? 3.7 between this. Then this will be from this to this. It will be 7.4 volt. From this level to this level, it is how much? Anyone? 10.1 or 11.1? 11.1. 10.4 plus 3.7. I'm just adding. And what will be the last level from here to here? From plus to minus 3.7 into 4. That is 14.8.
Yes, 14.8.
14.8. Now, why I have showed levels here is because a BMS actually needs to sense each level. So you need how much connection, to the BMS? This is first connection. This is the second connection. This is the third connection. Correct. And fourth connection and the fifth connection. In short, to easy to remember way, अगर मैं बोलूं तो अगर 4 लेवल्स है तो 5 कनेक्शन BMS को जाएंगे, 5 लेवल्स जाएंगे. Getting my point? क्या बोल रहा हूं मैं? I hope मेरी वॉइस और एवरीथिंग ओके.
Yes, yes.
Repeat it. सिंपल. क्या अगर मेरे 4 सेल्स है, 4 वोल्टेज लेवल्स है, 3.7, 7.4, 11.1 एंड 14.8. अगर ऐसे 4 लेवल्स है तो 5 कनेक्शन लगते हैं BMS को. तो अगर 16 लेवल्स है, 16 सेल्स है ना, तो कितने कनेक्शन आएंगे BMS को? 17, इंक्लूडिंग द 01.
Yes, sir.
Okay, including the 01. So these are this connection. ये जो आपको दिख रहे हैं connection 1, 2, 3, 4 like this. There has to be a 17 connection. अब वो एक साथ हो या अलग अलग जगह पे हो, doesn't matter. But they will be having some levels to be measured. कोई भी BMS उठाइए आप, उसमें voltage levels mentioned होते हैं. उस voltage levels को हम ऐसे connect करते हैं. 0 level, 3.7 level, जो भी है. करेक्ट. तो जितने एस होंगे, जितने सीरीज होंगे, उस हिसाब से आपके लेवल्स BMS को कनेक्ट होंगे. तो ये आपका BMS कार्ड है, स्लेव BMS. क्यों स्लेव BMS? ये हर एक पैक के साथ है.
अभी ये जो ब्लेड सेल है तो इसमें तो एक ही BMS होगा सर.
यस, एक ही BMS होगा, पर उसमें 17 लेवल्स होंगे. 17 लेवल्स चेक करेगा.
इसमें तो वो है ना, एक सिंगल BMS में काम होगा.
करेक्ट. वही दिखाई दे.
मॉड्यूल के कंपेयर में तो कम हो गया ना कॉस्टिंग भी.
करेक्ट. BMS काउंट भी कम हो गया.
यस.
16 को एक ही अकेला हैंडल कर रहा है.
एंड अगर कुछ भी अगर इश्यूज आएगा तो डायग्नोस करने में इजी होगा.
इजी हो जाएगा. करेक्ट.
सर जब ये 16 का एक मॉडल है, आप वहाँ BMS आके 48 वोल्ट का BMS है और 200 एम्प, सपोज 200 और 300 एम्प का एक BMS है. बट जब हम सभी को सीरीज में लगाएंगे, वहाँ 400 वोल्ट आ रहा है, तो जो फाइनल BMS लगेगा वो 400 एम्प्स का लगेगा.
नहीं, ये फाइनल BMS ही है.
नहीं,
ये एक स्लेव BMS है ना. स्लेव BMS है. आपका पॉइंट मैं बोलता हूँ, इसलिए तो अभी ब्लेड LFP के बारे में बोलेंगे. देखो, आपने बोला कि जो मास्टर BMS है उसका करंट डबल हो जाएगा. कैसे? क्या सब तो सीरीज में है ना.
हाँ,
सभी तो सीरीज में तो करंट सेम रहेगा ना. तो जो रेटिंग मेरे एक BMS का है करंट का, क्या वही रेटिंग मेरे मेन BMS का नहीं चलेगा?
हेलो सर.
हाँ, यस, बोलिए.
BMS क्या होता है सर, जरा समझाएंगे सर? कैसे वर्क करता है, क्या होता है?
बैटरी मैनेजमेंट सिस्टम क्या होता है कि उसमें 2 कैटेगरी होते हैं. एक होता है विद कंट्रोलर माइक्रो कंट्रोलर और एक होता है विदाउट माइक्रो कंट्रोलर जिसमें खाली कंपैरेटर्स होता है। अगर आप इंटरेस्टेड हो ना तो आप क्या कर सकते हैं इसमें ना चैट में लिख सकते हैं वी वांट अनदर सेशन बेस्ड ऑन ओनली बीएमएस। तो हम क्या करेंगे जितने एंट्रीज है बिकॉज वो ऐसा टॉपिक है कि अभी 10-15 मिनट में मैं एक्सप्लेन नहीं कर पाऊंगा इतना अच्छे से, उसके लिए बहुत आपको 1-2 घंटा और लगेगा, बराबर कि नहीं?
सर मेरा एक क्वेश्चन है सर। हेलो
हाँ बोलिए
सर, मैं ये पूछ रहा था एक मॉडल का जो आपने बीएमएस बोला है 48 वोल्ट का जो बीएमएस है और 200 एम्प्स मैंने 200 एच का जो है बीएमएस लगा हुआ है एक मॉडल में, करेक्ट? वो मॉडल आके सेकंड मॉडल से फिर सीरीज में कनेक्ट हो रहा है, करेक्ट?
हाँ करेक्ट।
तो हमारे को टोटल 8 मॉडल्स कनेक्ट हो रहे हैं ईच अदर, सो हमको लास्ट में 400 वोल्ट मिल रहा है।
यस 400 वोल्ट सीरीज में मिल रहा है, बराबर
सीरीज में मिल रहा है। तो हमारा जो मास्टर बीएमएस रहेगा वो तो 400 वोल्ट का रहेगा ना?
नहीं, अभी मैं आपको बोलता हूँ। यहाँ पे जो मास्टर बीएमएस है ना, करेक्ट, ओके, तो मास्टर बीएमएस क्या कर सकता है, इनका जो प्रोटेक्शंस है वो बराबर, करेक्ट, फाइन, इट कैन ओनली सेंस डिफरेंट वोल्टेज लेवल्स। और एक चीज है यहाँ पे जो आपका जो मॉड्यूल है ना, करेक्ट, यहाँ पे ये अगर आपका कंपैरेटर बेस रहा तो भी चलेगा, पर जो मास्टर होगा वो माइक्रो कंट्रोलर बेस रहेगा। माइक्रो कंट्रोलर बेस,
हाँ माइक्रो कंट्रोलर,
यस माइक्रो कंट्रोलर बेस। तो वो क्या करेगा कि कैन कम्युनिकेशन रहेगा उसमें, कैन एच कैन एल वायर्स रहेंगे जो हर एक स्लेव बीएमएस से कम्युनिकेट करेंगे। तो हर एक स्लेव बीएमएस में भी एक माइक्रो कंट्रोलर होगा जो आपको क्या करेगा, डेटा ट्रांसफर करेगा कि वेदर उसका जो वोल्टेज रीडिंग है उसमें कुछ प्रॉब्लम है कि नहीं। Got it? So it do not need to monitor, yeah, it do not need to monitor complete 400 volt.
ओके, सो आप ये बोलना चाह रहे हैं जो हमारा रहेगा वो ओनली 48 वोल्ट को ही सेंस करेगा जो माइक्रो कंट्रोलर है ईच मॉडल को?
यस, अभी आप देखिए ना, आप ये जो लेवल है ना, ये लेवल देखिए ना, हर एक सेल का कितना लेवल है, 3.7। तो बीएमएस क्या करता है, बीएमएस की कनेक्शन जो है ना, 2 कनेक्शन, उनको सिर्फ एक सेल का ही वोल्टेज देखना है, एक सेल का वोल्टेज देखना है, उनको टोटल वोल्टेज ऐसा नहीं एसएच देखना है। वो क्या करेंगे, अगर हर एक सेल अच्छा काम कर रहा है मतलब सेल बैलेंस्ड है। गेटिंग इट?
तो मतलब सर एक बीएमएस पूरा स्लैब को कंट्रोल कर लेगा?
यस, कंट्रोल कर लेगा, बिकॉज उसके जो टैपिंग्स है ना, वो टैपिंग्स एक एक वोल्टेज लेवल को ही आपको सेंस करेंगे। किसी एक में भी अगर वोल्टेज लेवल में गड़बड़ हुई, लाइक सपोज ये 4 है, 4 में से ये वाला थोड़ा वीक हो गया मतलब ड्यूरिंग चार्जिंग स्लो चार्ज हो रहा है, करेक्ट है ना? तो बीएमएस को पता चल जाएगा, बीएमएस विल गिव अ सिग्नल कि सेल बैलेंसिंग नहीं हो रहा है।
सर इसमें सेल बैलेंसिंग भी रहेगा ना, एक्टिव बैलेंसर रहेगा, करेक्ट?
यस यस, तो वही बोला हूं, अगर आपको बीएमएस के ऊपर एक और सेशन चाहिए, डोंट वरी, वी विल टेक इट, बिकॉज अभी हम थोड़ा डाइवर्ट हो रहे हैं, बिकॉज और वशील सर का भी एक पार्ट है। ओके, सो नो प्रॉब्लम, यू कैन जस्ट मेंशन इन द चैट बॉक्स, यस वी नीड वन मोर सेशन बेस्ड ओनली ऑन द बीएमएस, देन वी कैन ट्राई टू कंप्लीट ओनली बीएमएस पार्ट इन दैट। ओके, लेट्स गो अहेड। ये आपको समझ में आया मॉड्यूल 1?
बहुत अच्छी तरह सर।
यस, थैंक यू सो मच। ओके, सो ये
आपने सर हिंदी में बोल के पूरा क्लियर कर दिया सर।
नहीं, एक्चुअली क्या है ना, हमको सबका ध्यान रखना पड़ता है, वी हैव टू लुक टेक केयर ऑफ ऑल इंटरनेशनल पार्टिसिपेंट एंड ऑल अक्रॉस इंडिया हूएवर आर इंटरेस्टेड इन अटेंडिंग दिस। तो सॉरी अगर थोड़ा लैंग्वेज यहाँ वहाँ हुआ रहेगा, बट वी विल ट्राई टू कंटेंट अच्छे से समझे।
बहुत उम्दा एक्सप्लेन किए सर आपने।
थैंक यू सो मच, योर फीडबैक इज वेरी वैल्यूएबल टू अस।
सर मैंने लास्ट में ज्वाइन किया, क्या ये रिकॉर्डेड लेक्चर वापस मिलेगा हमें?
मिल जाएगा, हमारी टेक टीम को मैं बोलता हूँ, आपको लिंक आपको मेल में शायद भेज देंगे वो, एटलीस्ट वीडियो तो नहीं पर एटलीस्ट आपको ये जो पीपीटीज हम बना रहे हैं वो तो हम ट्राई करेंगे कि आपको मिल जाए।
ओके, थैंक यू।
यस, तो आई होप ये अभी पूरा महिंद्रा की बैटरी का आपको समझ में आया। ये कैलकुलेशन हमने ऑलरेडी, आप इजीली अभी देख सकते हैं कैलकुलेशन क्या है ना? एक मॉड्यूल में 16 सेल्स, 8 सच मॉड्यूल, टोटल 128 सेल। ओके, टोटल वोल्टेज वी वांट इज 400, सो 3.2 into 1.8 कीजिए, 3.2 into 128, 3.2 into 128। ओके, तो आपने किया भी था वो, करेक्ट? कितना आया था? 3.2 into 128, 409, मतलब ऑलमोस्ट 410 वोल्ट आपको पूरा बैटरी का मिल रहा है। 410 और अच्छी है ना, अच्छा ही है ना, फुल चार्ज है तो 410 वोल्ट तक हो जाएगा। ओके, तो टोटल एनर्जी डिवाइडेड बाय बैटरी वोल्टेज है ना, तो टोटल इतना आया था आपको, करेक्ट? फाइन, यस। इंडिविजुअल सेल का कैपेसिटी, या सो ये आपके बैटरी के आउटपुट टर्मिनल्स है यहाँ से, करेक्ट? और इसके बाद यस, ये देखिए पूरा है नेगेटिव बस बार, करेक्ट? ये आपके ऊपर कनेक्टर्स दोनों साइड पे, देखो रियर साइड पे भी और फ्रंट साइड पे भी। कैन यू सी द कनेक्शंस? ये आपका बीएमएस और ये आपका इंसुलेटिंग कवर, प्रोटेक्शन कवर, क्लियर? अब इसमें कूलिंग का कैसा है, ये आपका CSC मींस सेल सुपरवाइजर सर्किट, मतलब बीएमएस ही है, उसको नाम बीएमएस है, करेक्ट? अदर नेम इज CSC, सेल सुपरवाइजर सर्किट। सो ये जो है ये अपना वोल्टेज सेंस है, और यहाँ पे जब आपको जो केबल दिख रहा है, करेक्ट, ये टेम्परेचर सेंसर्स है। So temperature is also monitored of complete, you can say module. Complete module temperature is also monitored here.
Cell
Okay.
supervisor circuit.
Yes. Here, see this. Okay. So I guess this is how it is locked. The BMS part is locked with this. Okay. Now what we can do is, yes. अभी यहाँ पे जो part है thermal conductivity का, वो आपको वशील सर कंटिन्यू करेंगे, चलेगा?
चलेगा।
Yes. Okay. So with this, yes, I hope this is a complete pack. ये आपका DC in, DC to the DC out to the motor controller, DC in, correct? ये आपका breather ball या pressure exit ball, correct? और फिर आपको इसमें हर एक कवर के नीचे ना थर्मली कोरुगेटेड ऐसे ये दिखेंगे लाइंस, जो आपको वशील सर अभी समझाई देंगे कि थर्मली कैसे इसको मैनेजमेंट करना है। यस, ओके।
हेलो सर,
बोलिए ना
सर। मैं पावर इलेक्ट्रॉनिक्स बैकग्राउंड से हूँ, तो आप डीसी कन्वर्टर का अगर आगे लेक्चर होगा क्या मोबिलिटी में, मतलब चार्जर में कैसा रहेगा?
कौन सा
इलेक्ट्रिक व्हीकल के ना मोबिलिटी करके?
यस।
और डीसी कन्वर्टर कैसा रहेगा, उसमें चार्जिंग
ये
कैसा
सब
रहेगा?
हम हमारे कोर्सेज में इंक्लूड करते ही हैं, पूरा पावर कन्वर्टर, डीसी कन्वर्टर, मोटर कंट्रोलर में भी आपके एल्गोरिथम्स है, आपका डीडीसी है, आपका यू कैन से मतलब डायरेक्ट टॉप कंट्रोल होता है, या फ्लक्स एफओसी रहता है, फ्लक्स ओरिएंटेड कंट्रोल होता है। तो ये सब वाया पावर इलेक्ट्रॉनिक्स कैसे करना है वो सब भी हम सिखाते हैं।
कहाँ मिलेगा मुझे ये कोर्स?
सर वन क्वेश्चन।
हाँ, यस यस
सर
yes, Sapna ma'am, I guess Sapna ma'am.
yes sir, I'm sorry.
Yes, yeah, go ahead, I can recognize your voice. Yeah,
okay sir. Sir, if we connected all the cells in series, otherwise in parallel, which is preferred good? Here we see both combinations of them
available. Correct. I'll try to have my lesser ampere hour, you can say lesser C rate. Means one C rate should not stand to 100 ampere hour or 200 ampere hour, or 200 amperes.
So what is the combination of C rate?
C rate, yeah. I'll explain here. Will it be okay? Like this, yeah. See, if I say my battery is of 100 ampere hour, so one C rate for such battery is 100 amperes time. You can say current taken for time of 1 hour. So what is charge? Q is 100 ampere hour. So charge is current into time. Correct? Yes. So it is how much? 100 means what? To charge this battery of 100 ampere hour, I need to take 100 ampere current for 1 hour. But if I want, if I want 2C for the same battery, 2C means I'll take 200 amperes and the charging time will be only 0.5 or half hour. Again, the capacity will come out to be 100 ampere.
The time will be half here.
Yes. So 2C means faster charging,
faster charger
and higher current.
Okay.
सर ये ब्लेड सेल का क्या सी रेटिंग है सर?
Which one?
ब्लेड सेल जो यूज हो रहा है इसमें, व्हाट इज द सी रेटिंग? मींस व्हाट दिस महिंद्रा यूजिंग फॉर B9, व्हाट इज द सी रेटिंग?
ये इसका ना अपने ब्लेड एलएफपी का
जो 200 है, सी रेटिंग क्या है सर?
यस, इधर नाउ सी एटलीस्ट इट इज एक्सपेक्टेड एलएफपी जो है, करेक्ट? दैट्स व्हाई सी, अगर आप ध्यान से ये वाले स्लाइड जो मैडम ने लिए थे, आपको यहाँ पे भी बताता हूँ, लाइक यहाँ पे मैडम ने आपको LFP बताया था. Yes, correct. C. How much is typical C rate?
1C.
1C, typical C rate.
Yes.
So if you have 192 ampere hour, so how much current will be required then? 1C के लिए max 192 amperes.
Yes, similar.
Correct, but
one,
it doesn't mean I can't charge it with 2C. I can charge it. Correct. In that case, what will be the current? Lesser?
Yeah.
Correct. How much it will be?
Yes.
86.
Yes.
2C is fine.
Yes,
2C
yes.
is fine. 10C for the such battery. If I do 10C charging rate, then it is difficult. Correct. So if my charging station has 2C or 3C capability, my battery can take it, no problem. Clear?
Clear.
Yes.
यस क्लियर सर. उन्होंने क्योंकि जो चार्जिंग रेट काफी फास्ट दिया है ना, इसलिए पूछ रहा था. मैंने कहा सी रेटिंग क्या है.
यस. नाउ देखो सी रेट है ना बैटरी का मेंशन है, बट दैट डजंट मीन कि वो उतना ही करंट ड्रॉ करेगा. वो डिपेंड करेगा चार्जर का आपका पावर आउटपुट कैसा है, उस हिसाब से वो करंट ड्रॉ करेगा. आपका चार्जर के कनेक्शंस होता है, आपका व्हीकल का एक कनेक्टर होगा, आपका चार्जिंग स्टेशन का एक कनेक्टर होगा, उसमें कम्युनिकेशन होगा. करेक्ट. CP, CC, दिस विल कम इनटू प्ले एंड दैट विल डिसाइड कितना करंट बैटरी में इंड्यूस करना है. गॉट इट?
ओके.
यस. Okay, yeah, sorry Vasheel sir, it's too late, but I hope you can continue from here.
Sir, can
Okay,
you
sir,
tell me the words, please?
Yes, we will tell our team to give you this on your you can say link. Yeah.
Okay sir, thank you.
Okay.
Yeah, thank you sir.
Hello guys, is my screen visible?
Yes, visible.
Yes.
Okay.
Yes.
Okay. So Prasad sir has taken about your Mahindra's battery packs architecture. Okay. So now we're gonna see its core cooling system, how it has been done. Okay. यहाँ पर हम cooling system देख रहे हैं. Okay. अभी.
Yes.
Okay. So यहाँ पर okay, here what we have, each module. Okay. This is your module. Okay. Under the module we have your this material called as thermal interface material. Okay. We have thermal interface material. Then we have your cooling plate. Okay. So this is your bottom type of cooling plate. Okay. और end plate. Okay. So यहाँ पर ये bottom पर हम cooling plate लगाएंगे. Okay. और module और cooling के between हम ये thermal interface material लगाएंगे. Okay. क्योंकि ये यूनिफॉर्म, ये आपका बैटरी है ना, यहाँ पर कैन से अनइवन सरफेस होगा. हम आंखें से देख रहे हैं वो इवन होगा, बट इसका माइक्रो लेयर वो अनइवन होगा. सम पार्ट्स विल बी अनइवन. ओके. टू मेक इट इवन वी आर यूजिंग थर्मल इंटरफेस मटेरियल. ओके. एंड इसको स्ट्रक्चरल ये और ये एड्रेसिव है, मतलब ये आपका बैटरी ब्लेड को होल्ड करेगा. ओके. नॉट मेक इट मूव और वाइब्रेट. ओके. तो ये दो एडवांटेज है. ओके. और इसको प्रोटेक्ट करने के लिए बॉटम पर हम ये एक बॉटम कवर लगाएंगे. ओके. सो इसके एक गैप होगा 15 mm का गैप हम लीव करेंगे. ओके. सो यहाँ पर है ना आपका ये है ना, आप यहाँ पर हम थर्मल पेस्ट लगाएगी. ओके. इसके ऊपर हम बैटरी को स्टैक करेंगे. ओके. तो
थर्मल पेड
thermal interface paste. Okay. So इस तरफ like this we will apply. Okay. So ये ना एक सेकेंड. Okay. So ये एक सैंपल thermal interface material वो यूज कर रहे हैं. Okay. So इस ये ना सिर्फ ये एक पॉली इथेन बेस्ड एड्रेसिव। इसका मतलब क्या है, ये पॉलीमर, पॉलीमर का मतलब आपका कार्बन हाइड्रोजन ऑक्सीजन दोनों एक बॉन्ड करेगा और इसके भी एक रेडिकल होगा, वो नाइट्रोजन कार्बन ऑक्साइड, ओके, और आइसोसनेट बोलेगी, ओके। सो ये है ना इसका मटेरियल यूज करें। इसका एडवांटेज क्या है, इट हैज एडवांटेज ऑफ हाई बॉन्ड स्ट्रेंथ, फर्स्ट thermal stability, okay, thermal stability, then zero gap bonding, जिसका मतलब कोई गैप नहीं होगा एयर को, there will be pure no gaps, okay, between your module and your cooling plate, okay. So this will fill all gaps so that we don't have any air vacant, there is no vacant, यहाँ पर कोई vacant नहीं है, okay, in micro level, okay, in micro level, okay, clear है?
Yes, sir. Yes.
ओके, देन यहाँ पर हम देख रहे हो ये है वो ये एड्रेस है, ओके, देख रहे हो यहाँ पर, ओके, ये है ना आपका एड्रेस, ओके। देन अब आपका थर्मल इंटरफेस मटेरियल पूरा हो गया। नाउ थर्मल इंटरफेस मटेरियल इज डन। नेक्स्ट इज योर कूलिंग प्लेट, ओके। सो फॉर कूलिंग प्लेट वी यूज योर liquid cooling, okay. So here we split your plate, okay. I'm going to split my plate into two sections. Why? Here you can see this path, right? I'm going to split it. So this has been split into two sides, right? Because kya hai na, if one side है एक ही can say like एक ही section है को यहाँ पर more length होगा cover करने के लिए. If more length is there, it will be less efficient because starting stage पर वो easily thermal transfer करेगा, but as it travels, its efficiency to dissipate heat will decrease, okay. इसलिए हम ये इनलेट ये कूलिंग प्लेट को स्प्लिट करेगा दो साइज पर, ओके, दो साइज पर स्प्लिट करके ये दोनों मर्ज करेगा, ओके। तो ये आपका इनलेट, ये है ना आपका इनलेट वन और ये आपका इनलेट 2, ओके। सो ये है ना आपका आउटलेट, ओके। तो यहाँ पर you can see this is been split into two, okay, and are merged at the end, okay. So two inlet channel, inlet sides, okay, and one outlet, okay. So this is to parallelly, okay. At the same time, these are being cooled out. If I have one channel, means what happens? First, the top will cool, then only the bottom will get the chance to get cool, right? But यहाँ पर क्या हो रहा है? At the same time, ये top side भी cool हो रहा है और bottom side भी same simultaneously cool हो रहा है, okay? Clear है? क्यों यहाँ पर ये split हो रहा है, separate कर रहे हैं inlet 1 और 2?
Yes, sir.
Okay, then यहाँ पर आपका साइज, ओके। सो यहाँ पर आपका आउटलेट है ना वो बड़ा होगा इनलेट के बिना। क्यों है? योर आउटलेट इज बिगर कंपेयर टू इनलेट, व्हाई? I tell you, outlet is bigger compared to inlet. You just tell me why. What's the reason?
There are two inlets, no, sir?
Hmm?
Because there are two inlets.
Because you have two inlets.
Yeah, two inlets. First, one reason, two inlets. Okay. Another. So you know the formula PV is equal to nRT. What happens if temperature increase means either we need to increase the pressure or either pressure is increased or volume is increased, right? तो यहाँ पर क्या हो रहा है, आपका इनलेट से हॉट लिक्विड आ रहा है. सो इफ आई डोंट इंक्रीज माई वॉल्यूम, इसका प्रेशर बढ़ाएगा. प्रेशर बढ़ाएगा मतलब क्या होगा, डैमेज होगा. ओके, एक्सपांड नहीं हो रहा है. ओके, आपका हीट को फ्रीली एक्सपांड नहीं हो रहा है, उसको स्ट्रेच हो रहा है. ओके, तो यहाँ पर स्ट्रेन क्रिएट होगा. ओके, ये प्रेशर आपका चैनल पर स्ट्रेन क्रिएट होगा. दिस विल क्रिएट स्ट्रेन इन योर channel. Okay, clear? Yes, that's why I'm having a bigger channel in outlet. Okay, Then next is your uneven channels. Okay, so यहाँ पर if you just see at these ends, okay, where we don't have your is where
Sir,
there is no critical. Yeah, one second. Yes.
स्क्रीन पे वीडियो नहीं आ रहा
Screen share नहीं हो रहा है. It's just visible, right?
Yes, sir. Visual.
Okay.
Visual, sir.
Okay. Okay, then we just continue. Okay.
क्लियर नहीं हो रहा है सर
Okay. See here.
There is a corrugated type of the pattern are used. Why it is used over the casing? Corrugated pattern over the casing.
You are saying this pattern like this.
Yeah.
This pattern you are saying.
Why it is used?
This is like I can say like if I just give the straight way, okay. When there is motion means I will just say you stay straight, okay. You can't the energy you can't able to spend it, right? If I just moving means the energy will be going out, right? So I'm creating obstacles so that the liquid will become turbulent, which will increase its efficient heat transfer. Okay. If I give straight means there won't be any kinetic energy for it to transfer. कन्वेक्शन का मतलब क्या है? आपका कंडक्टर है, उसके पार आपका कन्वेक्शन मॉलिक्यूल्स है, वो ये हीट को ट्रांसफर करेगा, राइट? तो हीट को हम डिसिपेट करना है ना, सो बार मूव करने के बाद भी ये इजीली डिसिपेट हो सकता है. ओके, इसलिए यहाँ पर ये इंस्टेड ऑफ हैविंग स्ट्रेट लाइंस वी आर हैविंग दिस कर्वी लाइन. ओके.
Okay, sir. So we can say that these are conduction as well as the conduction as well as convection. Both
This is
will
to better your convection. No. This is convection only. Liquid, conductor and liquid is convection only. This is to increase your convection rate. Increase my heat convection rate. Okay.
Okay.
Okay. So यहाँ पर you can see this side the channel is bigger. Okay. But here in the critical spots where it touches with your can see blade battery, it is narrow. Okay. So why is that? So because the smaller channels, else your fluid will have time. Your fluid will be down. Okay. And the temperature it can able to take it. It can able to take it away from your blade. Okay. Whereas in the bigger side, this is helps it to expand. Okay. So here it is critical points where I have narrow flow for it to grab the temperature, grab the heat from your blade battery. Okay. Whereas here I need to make them expand. Okay. For it to move to the other places. Okay. For it to move to the other channel. Okay. क्लियर है? यहाँ पर क्रिटिकल पार्ट पर हम नैरो यूज करेंगी. ओके. फॉर बेटर हीट ट्रांसफर और लेस क्रिटिकल पार्ट पर हम वाइडर चैनल यूज करेंगी फॉर बेटर फ्लो. ओके. फॉर इजी फ्लो. ओके. ओके.
सर एक क्वेश्चन सर ये जो ब्लेड बैटरी जो माउंट कर रखा है ये हॉरिजॉन्टली है कि वर्टिकली है सर? ये अभी इसका कितना सरफेस एरिया आएगा ईच?
आपका सरफेस एरिया ना आप यहाँ पर इसलिए माउंट कर रहे हैं. ओके. वो लेंथ पर माउंट कर रहे हैं. ओके.
लेंथ पे हो रहा है ना?
ये लेंथ पर हो रहा है. ओके. सो द लेंथ इज कवर योर मॉड्यूल लेंथ. सो इट इज योर मॉड्यूल लेंथ. ओके.
मॉड्यूल लेंथ. ओके.
मॉड्यूल का लेंथ है ना वो पर एग्जैक्टली होगा. ओके. 16 स्टैक्ड होगा.
बोथ साइड अप एंड डाउन बोथ साइड करेक्ट?
Up and down both sides?
Only down side.
Only down. Yes.
Then what about the top then, sir?
Top you have the cover. Top cover we have.
Only the cover.
Cooling plate is in the bottom, not in top.
Okay.
One inside we have the cooling. Okay.
Okay, one side. Okay.
Yes.
Okay.
So that's it all about your cooling. Okay. So if you have any doubts, you can ask. Okay.
About thermal conductivity.
Yeah.
Hello, sir.
Dinesh or Sapna, anyone?
Sir, in previous topic, you show the thermal runaway. Previous, sir. Sir, if we apply the force in all place, then what happened? Here only shows the one spot pressure is shown, sir.
No, not one spot pressure. Okay. Here, you can say like this has been forced where you need your critical spot. Critical spot ka matlab kya hai? Here, if you have module, okay, under this you have this channel, right? So these are your critical spots. Okay. So this is where you have narrow strips. Okay. So this does not hamper your thermal runaway and all, because this doesn't directly contact with your battery and all. You have a material. Okay, we have a paste, right? Thermal runaway, and this is different. This is to prevent thermal runaway. Okay, this is to dissipate the heat before it reaches the critical point. There will be a critical point. After that, I can able to prevent it. It will just propagate. I just need to shut down my battery. To prevent that point to come, you should stop that from coming to the point. I need a better cooling. Okay.
Sir, one doubt, sir. Yeah, sir, one doubt. Is not covering the entire cell, correct? The cooling for each cell is not covering entire portion. Is only the bottom. I think one strip.
Yes, yes. See, yeah, because see, this is the thing. This is your blade battery pack. It has the width small, length bigger. Okay.
Yes.
Width small means what? I don't need to have top and bottom. It's waste. It's just expensive, right?
Okay.
Easily can able to cover because this width is small. If it is bigger width means it takes longer time for the heat from bottom to go top, right? Or the place of the cooling plate to the not place. Okay, but this width is small, right? So heat transfer won't be that much matter. Okay, we don't need to have another plate, or we don't need to have some pipe that goes to here. Okay, we don't need to have pipes like this. So this will.
We have only in the bottom.
Yeah, we are putting only in the bottom. Okay.
Not inside or anywhere.
No, not inside, not in anywhere. We're just putting in the bottom.
Bottom. Okay. Okay.
Yes.
I have a question. Yeah.
Yes.
What fluid is used for cooling, and where is the source of the cooling fluid? Yeah.
Okay, you're saying what coolant we use, right?
Correct.
I think one second. Let me just check. Okay.
And where is the source of the cooling fluid? Yeah. Where is it coming from?
See, cooling source is come from here. These are your outlets, nozzle. So pump. Okay, that is outside here. Okay. So we use.
So when it leaves the battery, where does it go?
See, we have this. You can say like this will be you can say like a flow chain. Okay, just put here. Okay. So here, if you have pump. Okay. So this is your battery pack. Okay. One side it will enter, another side it will exit. Okay.
Yes.
The excess we have a pressure relief valve that will be have some storage, temporary storage we have. Okay.
Okay. Okay.
Okay. And we use mostly ethylene glycol. We use ethylene glycol, or propylene glycol. Okay. Yeah. Alcohol based liquids. Okay.
Okay.
Okay. Okay then.
Okay.
Then Prasad will take you a summary.
Yeah, thank you, Vasheel. Yes, so to have a short revision of what we have done, simple, I'll just tell you those who have missed from the start. Okay, just a 5-minute quick revision. Is my screen visible? Correct? Yes, everyone?
Okay.
Yes? Okay.
Yes.
Yeah, so initially, Divyavani ma'am started with this, okay, cycle of a life cycle of a battery, okay, fine. And then after that, she discriminated between this lithium ion battery, advantage, disadvantage, and comparison with the different batteries chemistry. Okay, fine. So after different battery chemistry, Why lithium ion battery pack is preferred? Because of the high specific energy density and high volumetric energy density. Because of high specific energy density, the weight will be less. Okay, for the same energy, weight of the lithium ion battery is less than compared to the other battery packs. Okay, and also it has got high volumetric energy density. Means what? The space required for the same energy will be less as compared to the other battery pack. So saving in both, saving in weight and saving in volume if you use lithium ion. Okay, then she talked about the battery components, anode, cathode, and one battery pack also she shown, correct, of Volkswagen. And then she compared again different battery chemistry of lithium ion itself. Okay, out of which you might have seen the cobalt will be little bit dangerous. The one battery pack which has cobalt inside, okay, as quietly you can say not that safe. So safety will be lesser of those batteries, but those are not having cobalt content definitely will be more safer. Okay, after that we she started with this form factor. Okay, cylindrical prismatic pouch, and Vasheel sir took you through the blade LFP battery pack. Okay, then after that I took over with this series and parallel. What happens in series? Okay, what happens in series? The voltage is increased, capacity remains same. In parallel, voltage remains same, capacity increases. Okay, fine. And then depending on the capacity required, okay, you decide the number of parallel path. Depending on the voltage required, total voltage required, you decide the number of series path. Okay, and then how a battery pack is designed from cell level to pack level, that we have seen. We have compared two energy battery pack which are having same energy, but the one in which there are voltage is high, less number of parallel path, will require less C rate. Okay, and the losses will be also less. Okay, then after that we have seen this good video about battery pack. Okay, making a battery pack. Then we went to the Mahindra B, correct, having blade LFP, and how many 128 cells are required total, okay, of blade LFP to make this battery pack. And the capacity, total capacity is how much? Total capacity 198 ampere hour, correct. Okay, if you go by 400 volt. If you go by total voltage, that is 3.2 into 128, then this will be again less. Okay, then after that we have seen how the connections are made. Okay, how the BMS is integrated with this module, and how a master BMS and slave BMS work. Okay, so these calculations and all we have seen. Clear? And after that you have seen about the cooling part. Okay, from Vasheel sir. Fine. Clear with this? Okay, this was regarding our webinar. Okay, deep dive
Yes.
back right from basic. Yes. Any doubt? I hope before I asking doubt, I hope people have filled in the link to get a certification. Yeah. Yes. Any doubt, or is the clear summary is clear? Everything okay?
Hello, sir.
Yes. Yes.
I have small question.
Yes.
घड़ी पे सेल इम्बैलेंस हुआ तो इसका रिजोल्यूशन क्या दे सकते हैं?
किसका?
बैटरी का
हाँ,
सेल इम्बैलेंस हुआ तो
हाँ 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 cell imbalance, yeah, cell imbalance हुआ तो BMS will take care of it. Okay, BMS will have topologies. Okay, wherein active cell balancing is there. Generally, we prefer active cell balancing. In that, the charge from alpha cell, we call it as alpha cell. So charge from alpha cell is diverted to the weak cell for a momentary period of time, so that the capacity is same. Correct. Okay. So this is done by the BMS, active cell balancing.
Yes.
Okay.
Okay, I hope that's enough from our end. Any team member wants to go ahead with it? Like, yes. Yes. Fine. So if all doubts and everything is done, it was nice really connecting with so many enthusiastic brains. Okay, we really feel good. Okay, thank you for all your support. Yeah. If you have your email ID will be registered, okay, so you will get this PPT from our end. Yeah.
Okay.
Okay. Okay.
Shukriya.
Thank you, thank you, thank you,
Thank you,
everyone.
sir.
Thank you.
so much.
Thank you, sir. Thank you.
Thank you, sir.
Good night, everyone. Good night.
Good night, sir. Thank you.
Yeah, welcome.
Good day, sir.
Thank you.
Yes. Yeah.
Thank you, sir. Thank you.
Welcome. You're most welcome.
Asante
Thank you,
from
everyone.
Nairobi, Kenya.
Yes, yes. Yeah. That,
Okay, tomorrow same time, sir.
that our team will let you know. Yeah, our team will circulate necessary message regarding further part. Okay, and then we'll get back to you.
Hello, sir.
Yes. Chaitanya.
Today's webinar is free webinar. Yesterday, tomorrow also will be free, or it will be like a paid.
Yeah, that our team will decide and let you know. Yeah. Thank you, Manoj ji. Thank you.
Okay.
Yeah. See, more the participants are interested, more we will be able to keep such webinar. Yeah. Fine. So you can make a
Sure.
in that form you can mention, okay, we want it for this BMS also. Yeah. Yeah. Thank you, Prachi. Thank you so much.
Okay, sir. Thank you.
Yeah, thank you.
हेलो सर
Yes.
सर कंपनीज वगैरह के बारे में बताना सर, जैसे सर्टिफिकेट वगैरह और जैसे रिज्यूमे वगैरह जैसे बनाते हैं तो कंपनीज वगैरह में कैसे क्या सेंड करना होता है।
हाँ, सी हमारी एक प्लेसमेंट की टीम है, करेक्ट, वो ये सब आपके लिए सेपरेट सेशन रखती है। ठीक है।
फ्रॉम इंटरसाला सर।
हाँ, यस।
एक्चुअली आई एम कोर्स ऑफ ईवी फ्रॉम इंटरसाला।
ओके ओके ओके। हाँ, सो सी अभी आप 4 सेक्शंस तो रखिए जो आप एलिब्रेट करना चाहेंगे सीवी में। ओके, first is what knowledge you have from mechanical or electrical or electronics. Suppose you have mechanical knowledge, you can elaborate more about SolidWorks, ANSYS, and the analysis of thermal management system of a battery pack, or analysis of complete EV, correct, which you can do on SolidWorks, ANSYS, CATIA, correct. That is one thing you can mention in your CV. Second is regarding you can say your embedded system. Okay, if you are good, if you are from electrical electronics, you can mention more about the embedded system. You have learned STM32 microcontrollers, communication between two controllers using CAN communication. That you can elaborate, which we do actually, correct. And then the third part is regarding the MATLAB. Okay, yes. So if you elaborate, if you are good enough in MATLAB also in research level, generally high-paid jobs are in embedded and MATLAB and design. Okay, mere knowing the power converters connection and the motor controller connection and the battery pack connection, that will only offer you say service engineer job. If you want to look beyond service engineer jobs, then you have to know much detail about the MATLAB simulations and SolidWorks design and the embedded part. This will include your. This will make your CV more visible. Okay.
Okay.
Yeah. Okay. Yes. So, thank you, everyone.
One doubt not clear, sir.
Yes, Sapna. Boli.
Sir, as Vasheel sir shows the video in this burning of battery cells.
Yeah. I got your doubt that sir showed you about one punch, a nail thorough test. Okay, what if the pressure comes to everywhere from each this thing, correct?
Yes, sir. Yes.
Yes. So see, generally what happens? No, my screen is presented here. Okay. Yeah. Can you see this?
Yes, sir.
What you see? Yeah, it's visible. Yeah. If you check, na, this battery pack has some projections outside. See. Can you see this? Outside projections? Yeah.
Yes.
These are for side impacts. Okay. And this member is also preventing it. So whatever impact is there, okay, most probably side impact. So you have your vehicle chassis and all, and on top you have this protrusions also. Sometimes it's called extrusions. What this do is it actually takes up a lot of impact, so that the battery will not be pierced in. Got it? Yes, see this. Understood? Yes. So in your in your battery pack, this is extrusion. See, extruded aluminum welded together. Correct? Okay. Fine. Yes. So this will take up the side impact. See, to handle 2 kilonewton side impact. Okay. Yes. Yeah. So sir has told you about it from the top. If it is pierced and all, what will happen? Correct.
Yes,
Yes.
sir. My doubt is
different. Yeah.
yes, sir.
No issue.
Sir, here,
Yeah.
sir, and you told is side of this length in side, sir. In
Correct.
top, in top of you, if we apply the force, what happened? I asked.
Yeah. See, now that depends whether the force you are applying is at one pinpoint or it is distributed one.
Yes, sir.
Correct. If it's a distributed one, the whole battery pack will take up, no problem. Whole battery module will take up. But if it's a pinpoint, then that much thrust we should have to pierce this battery. Correct.
I think so. There is need to understand more about this.
See, if you take one module, okay, separately, let us draw that module. Okay. Fine. Let us draw this module like this. Correct. Okay.
Yes,
Now what I am saying is, for damaging the battery at one point, you need lot of force. Correct. And for damaging the battery from all the ends, correct. Again, the force will be distributed, no?
Yes,
Your force
right,
will be distributed.
right.
Yes.
Now understand.
Yeah. See, you are saying if the lot of force comes from top, then what will happen?
Yes, sir. Yes.
Yeah. So that's what I'm explaining. If lot of force comes from the top, whether the force is acting at one point, single point, or whether the forces are acting at several points.
Yes, sir.
Correct. It is a real probability, 0.00001 probability that all such forces will act as pinpoint. Am I right? See, you will be sitting on the battery pack itself. Battery pack will be at the bottom. Correct. Then there will be a sitting arrangement over this. Correct. No. Chassis will be there, and then you can say your interior part will be there of the you can say vehicle. Correct. So
Yes,
what do you think? What are the chances of too many forces coming on the battery pack from the above?
I think so.
Yes.
When spot is high force, and if we apply more force in every place, there is some less.
Yes, then only the battery will get damaged.
Oh yes, sir.
Anyhow, Sapna ma'am wants to damage the battery. Okay, so for that, you see, think of it. How many forces you will require at one point acting together? Correct.
Yes, sir. Yes, sir.
Okay, so we need some kind of Hulk person to take the battery and bang it every time with that much force. Is it?
Sir, it also depends on material which we used in manufacturing of battery.
Correct. So that's what in LFP you check the material. Okay. So even if it gets punctured, no, it will express its pressure, release the pressure via fumes, not by flame. That's why LFP we are preferring. Got it? You will get fumes, smoke, and not the fires. Okay. I hope I cleared finally your doubt. Yeah. Okay.
Sir, thank you, sir.
Yeah, welcome. Yeah. Thank you, everyone. I'll stop.
Thank you, sir. Thank you so much. Good night.
Yes. Welcome. Good night.
Hello.
Hi. Yes.
Hello, sir. Sir, I have one
Yes.
solution. Sir, I have done diploma in
Okay.
automobile, and I have 2 experience in EV vehicles. I have know all mechanical,
Okay.
electrical
Okay.
components. So I'm decide to learn BMS software from basic to
Okay.
advanced.
Okay.
There is a best for me.
Yes. See, there are some courses available. Okay. 1 month, 3 months, 6 months courses are available. Okay, in DIYguru website. So you can connect with our sales team. They will tell you which course you should do. Professional certification is also there for BMS part, battery part. Okay, correct. Wherein you will learn the embedded system in the BMS required. Okay, and it will is your task to understand BMS component, cell level component, means chip level component. What kind of chips are there? Okay, fine. How many comparator ICs are there? Correct. What BMS does by sensing each level. Okay. Then how the gate of the MOSFETs are connected. Okay. That is charging MOSFET, discharging MOSFETs are there. So how they are connected. Gate of that are connected via this BMS circuit. Okay. So this all you will get to learn.
Sir, thank you.
Yeah. Welcome.